Really important.
I just can't see.
Try and get them used to right.
That's good. So it's created under you, under WestNet? Under WestNet.
So, how are we going to show on the people that are presenting? We're just going to turn it? Is that what we're going to aim it, or is there going to be another camera that's...
There's another camera.
Okay. We should get that taped down. That's a hazard.
I could ask a few folks if they could come check it for us. Isn't it called grip tape?
Yeah, gaffer's tape.
Gaffer's tape.
There's a lot of these
Because you never know where you need it.
Is Tim Urban actually here?
He's here. Tim's right over there.
Yeah, that's you can buy over $70 a month. What am I subsidizing? I think it's about the same. Yeah, it's like a month.
Yeah, it didn't copy.
Well, it was really great. So
As you search for IT security funding videos.
Outline from the circuit.
It got bumped up to 9:45. Yeah.
That's actually.
Should this one be muted?
So I have enjoyed up to that mic.
This one.
So it's just mic too.
That power mic.
That was-
Oh, thank you for bringing the tape. Appreciate it. Yeah, just this, we just don't want a trip hazard right there. Thank you.
It did get quiet. I don't know.
I know, I mean, one more minute till start time. It's like, we're getting close on our Google Hangout, so. Well, Marla, shall I go ahead and get us kicked off?
And
Okay.
you know we do introductions.
Yep. Well, welcome everyone. We're glad you could join us here at the University of Utah this time. We are really glad to host this time. Appreciate getting back together. A couple of logistics, restrooms. So the male and the female restrooms are opposite halls of each other. The fastest way to get to the men's is to go out this door at the back corner and just follow that hallway around to the back corner. Right as you come out that handicapped hallway, turn right, and the restroom's right there for the men. And then the women's restroom is just out this door and at the end of the hall, right in that corner of this hall. So Marla, of course, is reminding us all to be careful with our recyclables, use the correct recycle bin. We're grateful for Marla reminding us that. We've got the recycle bins right outside the door. Make sure you use recycling and do it appropriately. Quickly, Trevor was just telling me we've got about 9 people that haven't been able to get here yet, so we're down to 6. All right. Oh, Todd, yes. Hey, John. All right. So we're down to 6 that aren't here. So thank you all for making the effort to be here, and we're going to go ahead and do introductions. Some of the old timers will, say, well, I know everybody or almost everybody, but I think there's enough new people that it would be appropriate to go ahead and go around and do introductions. So Dave, you're on the front row. We'll just go ahead and start here with you, Dave, and just say who you are and where you're from, and then we'll go around the room.
Hi, I'm Dave, Master of Doom and Gloom from the University of Utah. Alex Shaw, network engineer from Network in Boulder.
Chad, or whatever, go ahead.
Chad Burnham, University of Denver, Director of Telecom.
Will Bass, University of Denver, Director of Computer Operations.
Trevor?
Oh, sorry. I was thinking parking for a minute. Trevor Long, University of Utah, glad to be here.
Eric Hawley, CIO, Utah State University.
Tim Bergman, network engineer, University of Utah.
John Moreland, new face, University of Utah with the Mike's NCI group.
And Alan Fox with Dixie State University.
I'm Vivian Guerrero, network engineer with FRGB in Boulder, Colorado.
Ben Mayfield, Addison University, network engineer.
Calvin Williams, network engineer at ISU.
Chuck Farron, network engineer, University of Colorado in Boulder.
Ryan Diamond, project manager, University of Arizona.
I'm Brennan, University of Denver.
Kelly McDonald, former assistant VP at BYU, and I believe I'm the longest attending WestNet member leadership.
I think you have a handstand.
No question. No question, Kelly. Rose?
Rose Villegas, business analyst for the University of Utah.
I'm Matt McLaren with Fort Lewis College, Director, CIO, Budget Manager, Administrative Assistant.
One match.
And we loved last year. Thank you.
So
were a great host last year. Thank you so much. Jim?
Jim Livingston, CTO with the University of Utah and University of North Carolina.
Mike Ruska, University of Idaho, network engineer.
Steve Lobas, Colorado State University, Information Security Officer.
James Isaac with Colorado State University. I'm Alex Schrock, I'm the CIO at Lewis Clark in Central Idaho, and I'm here representing the institutions that don't have as many resources as you do. And I'm here to make you feel better about that. So, thank you.
Elliot Fettig, University of Utah, IT manager with the Enterprise Monitor.
I'm Marla Beal. I work at the National Center for Atmospheric Research, University Corporation for Atmospheric Research, and I manage currently HDA Device Data Optical Network.
Barry Bryson, Associate Director, Utah Education Telehealth Network.
Scott Bailey from Colorado State University. I do a couple of regular sessions. I just send out an email about those for those who aren't familiar with what are you doing about and 5-minute madness. So these are sessions that require audience participation, and I look forward to yours.
Thanks, Scott.
So did we get everybody?
I think we did.
I think
Oh,
Skip
John Sutherland came around.
John Sutherland, Network Director, at least for the moment, at BYU.
Did we lose Michelle?
Yes, Michelle took a new job, and so while they were trying to find a new network director, I mean, she did a new job at BYU. So while they're trying to find a new network director, I volunteered to be the network director. So it is, the last time I did this, I was in a job for 9 months over servers and storage. So now I'm over in networking for a while.
Congratulations, John. Todd, did Todd get to introduce himself?
Oh, Todd is out paying parking. I told him that Dave Pershing would waive any parking ticket I got, but he doesn't believe me. So one of my hobbies is I'm really into engineering education. I chair the industry advisory board for the College of Engineering here at the U. And this year, through the legislation, we got an additional $1.5 million for engineering here at the U. They have to match it, so it's going to be a $3 million bump in the budget in the college there. And so when you do things like that and you help with stuff like that, then Dave Pershing tends to waive parking tickets for you. So,
well, you know, we could have helped too if that was a Dave would be happy to take care of it, I'm sure. But yeah, so Rich Brown's got another $3 million. That's awesome.
Yeah,
that's awesome. Great. Thank you,
there's
John.
probably 23 or 24 new faculty positions.
So Todd, go ahead and introduce yourself.
Todd Barrett from BYU. I'm in charge of our infrastructure group, so our network and our data center. And what else do you want to know?
Well, so does John officially report to you then? Is that the story now?
John reports to me here.
Sorry I have to give John a hard time, but John and I go way back, way back, clear back to the days when he was in Intel. Is there anything else, Marla, that you wanted us to cover as far as welcome and introductions?
If Mike's going to bring that up, you should know that he came to work as a student intern at Intel when I worked there and his brother. So that's how far back I know Mike.
Yeah, I was probably 21, 22, I don't know. It was pretty, so anything else, Marla, Scott, you guys seem to be the ones that know how best to run this. Is there anything else we need to cover?
I think you've covered it. Thank you for all attending, and my usual thanks to Utah for stepping up and hosting, and Alex and Dave and his team for supporting the Google Hangouts. I guess, is there anybody on the Hangouts that wants to introduce themselves? Is there anybody on the Hangout?
There's 2 viewers, it says.
One of them's us, so there might be another one. Can we tell who did?
So
I can set out the link for people to join. Most people are just viewing the sessions.
So I heard we had to readjust the schedule a little bit. What's the new agenda?
Yeah, so Jim Stewart's running a little late, so I've convinced Tim to go at 9:45, and then John and Neil, you'll go at 10:45, and then we'll put Jim at 11:15.
Is that earlier than planned?
Yes.
Yeah, for a half hour.
I bet half an hour.
Well, I don't know if we're going to be able to do that and see if Neil can make it.
Oh, well, Barry, do you think Jim can be here by 10:45?
Awesome medical text.
So who's next up then, Marla?
So, Chad, you're up.
All right, Chad.
Sure.
Anybody have a pointer?
You know, I didn't bring a pointer.
I've got one.
Oh, Ryan, thank you.
Alex has one too.
Oh, Alex has already given a pointer.
And what do I need to do to start it on Hangout?
Yeah.
Open it.
Yeah.
Are we sharing the screen already?
You may want to go, I don't know.
Is that good?
13.
Can you see that?
Go that way. They're down to one lane on the 215.
Yeah, I-15, I-80.
I mean, the third way open. Yeah. Okay. So you might do a little time. All right. Thanks. So.
The other one does this one do?
What did you use, Kelly? What was the end? Is that not list?
And I sent that, and I started to send a text message. You all get a text message from Kelly.
Just get a text message. I didn't get your message out.
That's because Marla announced.
Oh, so. Nobody else like Kelly's.
I got a
I had half a dozen people say they got it.
So Marla, Neil can make it earlier.
Okay.
So.
So you do. Thank you. All right, so some of you got the message. Did everybody get the message from me saying there's a new WestNet list? Maybe you did.
Yes.
Alex apparently is not home. Why would it go to some people and not others? Are you on the WestNet list?
So I have my old email on there. David's like, my friend.
And here's the jury's order list. Scott, did you get the message from me?
Well, that's all I got from you.
You didn't get one like, late in the day.
They also sent a questionnaire reminder last night to the new.
No, I didn't see that.
I got that.
No, I didn't see that.
But actually, I might have copied you, I said, actually, both, I carbon copied you, take that just in
Yeah, I
case.
kind of wondered when you did that. Right before you said, so we don't really have to.
Yeah, I probably should.
Good morning.
Good morning. My day's good.
It's okay.
They start this way and then they just continue this way. So, okay, well, that's weird. Why some people got.
So, in the spirit of WestNet, I'm continuing our long tradition of talking about network management tools. We seem to have a whole diverse population of tools and things we all use in our environments that are ever changing. And NetScout Ingenious One is one of those tools at the University of Denver. We have lots of tools. We have tool diversity as well. I'm going to try to just focus this talk on this tool. So here we go. I had to take a couple slides and some text from the vendor. I'm not here to evangelize the vendor, but I just thought they had a couple of good paragraphs that explain to you all what this tool is and how we're going to use it here at DU. We have the Ingenious One platform at DU. It's basically a VM that physical InfiniStreams feed into and virtual InfiniStreams. And I'm going to be showing you some screenshots of that. But basically, it allows us to define applications, and those could be databases, those could be a web app, those could be any app you can think of. In this case, we're going to talk about unified communications today and those apps. And really, we've taken that platform and tried to tune it towards UC. I'll show you some screenshots of some other things we've done with it. The idea is, if your help desk, your computer operations team, your database team, your web team, your network team, your telecom team, your security team, the idea is you're looking at the same packets and looking at the same information, you might yield the same results or reduce the time it takes to troubleshoot an application. The key to the application is having key places in your network where you're picking up on those packets. This is not a log aggregator. It can be a NetFlow collector. We don't use that at DU. Really, you're just looking at packet data and you're trying to determine from that packet data maybe the errors or problems with your given application. Getting buy-in has been a little difficult for me. All the folks involved when we bought it have left. So getting new directors and new CIOs into the NetScout story has been challenging for me. I've tried to really just focus on UC in the last year and a couple other apps. They have a patented ASI technology. It's their deep packet inspection engine. It allows us to collect these packets at rapid rates and write them to disk in memory very, 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 very quickly. So at the end of the day, their secret sauce is this patent called ASI, and I'm very proud of it. And that's really how they're able to just get that volume of data to disk and to storage. So think of it kind of as a TiVo for your network. It's really where all the packets are getting stored. And it's really just the header information and error codes. You have to decide if you want the full payload or not. When you get into voice communications, voice and video, the full payload can matter, especially if you're going to play back a phone call and listen to the poor quality later. So payload can be important, and you might need to record that. This is another one of their marketing slides. They're a couple $1 billion company. They've recently bought a bunch of other companies in the last year. One of them you might recognize in the middle is Arbor. Arbor came from I2, actually, University of Michigan, I think. And so that's their whole security side. We have not bought into that at DU. And they've bought into the air magnet piece. They have a huge wireless play. They bought some of the Fluke products, the Fluke air magnet, and a lot of other Fluke things they now own. There are other companies they bought out, Tektronix, which is another analyzing company. We're more on the left side of DU. We have taps, we have a packet flow switch, and then we have InfiniStream, NG, and then the top one is really the Ingenious One package that we're going to talk about. It's another one of their marketing slides that just kind of talk about some of the use cases. So for us, capacity planning, conversations. I use it for a change monitoring tool. I like to watch the application performance before a change and after a change and see what's going on. And their story is moving to the cloud. I'll talk a little bit more about that. But basically, their ability to measure that same packet data in the cloud, their products are evolving to handle that. So their last marketing slide. The idea is we basically have a network assurance, infrastructure assurance, cloud assurance, and together we can consolidate some of these tools and bridge silos in organizations to help get to the root cause of problems and performance issues. So switching gears, this is a slide I produced. I was at a NetScout conference. They asked me to speak in April, so some of my slides came from that conference. This is one of them. I put NetScout in the middle because I was at their conference. But at the end of the day, at DU, we've deployed call managers, Cisco Unity, instant messaging, mobile remote access, analog gateways. We have a prime collab deployment server, another monitoring server, Cisco emergency responder. We are a Red Sky Anywhere customer. We have a provisioning tool, auto attendant, paging server, contact centers, telepresence servers, Jabber Guest, Cisco Hybrid, WebEx. We're launching eFax right now. We're doing a call recording service right now, and we have an alumni giving project. And by the way, we got to get off our PRIs and get to SIP trunking. So this menu of things are really what me and my team are up to lately to effectively shut off a PDX that's end of sale, end of life, end of support. So I had to unpeel the onion as an assistant director and director and came to realize how many things we had bolted onto our PDX and how many things I had to replace just to turn off the PDX. And in the beginning, I was naive. Now I'm not so naive to telephony and running these types of services and really what our customers expect from us around the campus. So this represents all of these applications and servers that now I need to worry about. I need to make sure they're working, they're getting backed up, they're performing correctly. And if somebody calls me and says, well, the quality isn't good, I want to be able to go back and look at that later. That's what I'm using NetScout to help you with.
So you mentioned the payload is optional. How often do you, because that would be a huge storage problem. I mean, if you're actually storing the
For
payload.
video more so, not so much for voice, but yeah, you are correct. If you're gonna store payload of voice calls, you're in effect recording every call on your network. And NetScout is very cautious in advising you against that or for that. Call center applications, one-way audio, things going wrong in call centers, that's more your use case for recording all those calls. You need to enable some things on the device. You need to realize from a policy perspective, you're okay with recording phone calls. In the use case, we are not using encryption for our payload. It's very complex to do encryption in telephony in UC environment, although possible, but you need to load certificates now on phones, on computers, in the servers. Many NetScout customers do that, and you end up loading the encryption keys onto the NetScout infrastructure so that you can decrypt, so that you can hear the payload. So hopefully I've answered your question.
Yeah, I just wondered how often you do it, really. I mean, do you?
Yeah, really not often. Yeah, I mean, but if you've got somebody really high up that is upset that they can't hear the other person, you want to know why, and you want to hear that yourself, and it's a great tool to do that. So we added a module called the UC module to our NetScout deployment. It's an extra licensing. It was really a buyout from a company in Europe. And they bring the secret sauce to some of the screenshots I'm going to show you. But again, this is part of our larger Turn Down the PBX project. We needed to be able to monitor our environment day to day and be able to go back and look at events that happened in the past. The goal I've had is to enable our help desk, our analysts, our engineers with new tools to help them do their job and troubleshoot problems as tickets come in. So things like call search, user search, those are some examples of things you want to be able to do later. And then really to be able to replace a lot of reports that I had that were Perl scripts written on the old PBX to produce meaningful reports. So we've been trying to work on reporting as well. The tool does a good job of reporting. This is a diagram of our backbone. In the last year since I've seen you, I've spent a lot of time moving away from spanning and moving more towards taps. I have this advice to you, tap when you can, span when you must. I will say that over and over again, because putting high pressure on span engines is not good in your network, in your environment. So we've spent the last year tapping our links to and from the data center while we're still doing span sessions here and here. We've also tapped, I've simplified it here, but we have 4 wireless controllers, each with 2 10 gig links. All those are tapped now. And then we're tapping our 2 WAN links. And we'll probably be doing some additional taps as we deploy some firewalls in and out of the data center. We might tap on both sides of the firewall. So it's a simplified diagram, but really what gets challenging in all of our campus environments is how you're going to tap these dual 10 gig links or single 40s or single 100s. When you do like a diamond design like that, tapping that becomes harder. You need more taps, and then you've got to land those taps into some type of collection packet flow switch or span switch. Probably hard to see, but we have a single packet flow switch. It's a Net Optics. We're on our 4th year of it. We're looking at replacing it. But basically, we take in a lot of span sessions from the diamond I showed in the previous. And what's not shown here are all the taps that come into this same switch. And then we output, in this case, to the NetScout InfiniStream, which is a physical appliance with 4 10 gig interfaces. So based on rules on this switch, you take your sources of traffic and destine them to then these interfaces in the collector. I'm also showing some security products. We send similar data to our Metaflows IDS, our Darktrace, and our CopySense Verify. So it can double as a security tool, an infrastructure tool, and in this case, unified communications, or just general application performance collection. This would be what I would call an instrumentation strategy, and I have a new respect for that word after going to the NetScout their conference for 2 years. There's teams of people out there, all they do is instrumentation. They don't run networks, they don't run telephony, they don't run servers, they run instrumentation. And that's I've kind of elevated my awareness of that now. For NetScout to work correctly, you need to be instrumented properly in certain places in your network. I think all of us in this room have some sort of instrumentation going on now. My bet is you're gonna have to invest into it and improve upon it as the speeds and feeds continue to go up. This is a diagram one of my engineers put together to illustrate a virtual infinite stream. So imagine a collector of packets or deep packet inspection on a VM. And that's what we've done here with this graphic. And in our case, we're a VMware shop. So we're taking the VMware virtual distributed switch. We're taking collections from ESX hosts and we're pointing them towards a virtual collector. And that's called that a VI2000. They've just renamed it vStream to remain relevant in the next generation. So basically, what we've done is we've got some vStreams in our UC environment to help get at the packets near the servers. But I'll say to you, especially in unified communications, in a diagram like this, when you have voice and video going on, it's happening all over your network. When you pick up a phone and you dial someone's digits, maybe that call control is happening to and from your data center, but then the subsequent voice and video packets, they're going across your network phone to phone, phone to gateway, phone to internet. They're not always going to your data center. So it's important if you want to see a continuous call, you want to see the call setup, then you want to see the media flow, you need to be aware of where that's occurring in your network so that you're picking up on those packets so that the software can draw you this nice picture of what's happening in your network. That was elusive for us in the beginning. So here is a diagram, again, just showing those virtual infinite streams, which are drawn here off of a mirror port coming from the virtual distributed switch. And we've got a lot of our servers in different VLANs, so we're trunking, and these are some names of our servers back at those service items I showed you earlier. When we got into this over a year ago, we quickly realized we needed to re-architect our voice network and come up with a new IP scheme for voice across our campus. So what we did is we came up with new layer 2 VLANs. We mapped those to new layer 3 IPv4 subnets. In Cisco's world, they call those device pools. In Cisco Emergency Responder, they call those groups, URLs, and ELINs. In our paging software, that's a group. In NetScout, it's a combination of client communities and locations. And then in our provisioning tool, they're called sites. And I'm just showing you a small snippet of a couple of our buildings at DU where we basically incremented the third octet and incremented a VLAN number. And all in all, I'm providing voice and video for UC in about 100 locations. So we basically have 100 new subnets. But with that, we can see that traffic by location in NetScout later. And I'll show you why that's really useful. So for monitoring, it was good to re-architect. For reporting, it was good to re-architect. For troubleshooting, it was good to re-architect. And in effect, we're doing what some call diff services, differentiated services. We're differentiating between voice and data in a given building by going this direction.
Take a chat.
Yes.
How many buildings do you have on your campus?
We have about 85 on the campus, and we have about 15 WAN locations. So all in all, about 100 sites that we need to worry about. And so you've hit it there. What we did in the WAN is we incremented the second octet to tell you, oh, this is a WAN location rather than a campus LAN location. And as we all know, WAN locations are tougher to protect and keep good voice quality, especially with QoS issues, across other people's networks. This didn't scale well. This is a dashboard showing Ingenious One, where I'm showing you some service enablers like DHCP, LDAP, AD. This is a very short list. We've got about 80 different services defined that have nothing to do with UC, and those we've had around for a couple of years. It's the UC stuff that's new. So this didn't scale well on this PowerPoint. Here's an example of our dashboard for unified communications. This is my top level where you come in. You can say 7 days, different types of metrics. So in this case, we're experimenting with a few things, but at the end of the day, you want to look at performance of a given service, or you want to look at a performance of a given site, and that's why we re-architected. So here's an example of some of the services that I showed you earlier in the presentation. How's our contact center doing? How's unified messaging doing? Our voicemail goes out to Office 365, so there's communications between us and the cloud. We added a feature called Unified Voicemail Box. So when you get a voicemail at DU, we immediately put that in your inbox and we transcribe it. So that's a feature above and beyond the normal. But we want to look at the performance of that and see how that's performing. Because if you think about it, every time you get a voicemail, there's a bunch of back and forth between the cloud and your client to then present that voicemail in your inbox. So we want to see that traffic. Expressways are Cisco's terms for their border devices for mobile remote access. If I were to go into my voicemail or my call control here on my Jabber client, this Jabber client's really terminating on our expressway boxes. We're experimenting with people with phones at their house. You plug that phone into a house network, it's going to terminate on an expressway. We want to see that traffic and see the performance of that traffic. This is a locations example. Those subnets I showed you in the table earlier, we basically have a service card for every building on campus. I just ran this last night. I went back a week. We can see not a lot. You know, this house here, I'll tell you right now, has 5 phones in it. So in a week, they've had 915 transactions. This law school building is huge. In a week, we've had 12,000 transactions. So some of these buildings have hundreds of phones in them. Some of them just have a few. But the idea here is you can drill into any building at any time and look at the quality of the calls and video. By the way, we've deployed the Cisco 8845 phone with a camera on. When you make a phone call, if the camera's turned on, video traffic's traversing your network as well as voice. And then, of course, we have lots of buildings that don't have the cameras, and it's just voice. This is a screenshot of a whole building in 1 week. Where I show just some key graphs. You could drill. And I decided last night I can't have 50 slides to show you today of this drill. But your idea is you're a top level graph, you're drilling. You're right at a packet decode by the time you're done to really look at the packet, which is quick and nice. So here you're seeing payload stats, packet loss, degradation of MOS scores. In this case, 2,495 what they call streams. We've got some MOS problems, jitter, delay, things like that. This package has all these buttons that just get you boom, 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 right into what you need to see quickly, but you got to learn how to use the package and actually click on it. I'm going to talk about the MOS scores and packet loss in a second. There's situations in the package where basically they baseline a lot of your performance, and if you deviate from the baseline too far, they call that a situation. And you might be worried about that situation. You might want to drill into it, and I'll talk more about that in a minute. This is some of the secret sauce of the UC license. In this case, I drilled into a call that occurred last night while I was in my hotel room here. And we see a call going from our library, and there's all these radio buttons. I happen to pick loss and jitter, and we're seeing it leaving the handset in the library. We're seeing it head over to one of our gateways. So this user decided to dial 9 and go out to the public switch telephone network. And then we see the return traffic from the gateway going back to the phone. And then we see key points in our network where we're measuring that conversation. This package will draw this up to 5 deep. So if you can see the call in 5 places in your network, it's going to stitch it together for you and show it to you here, and maybe show you where you got a problem in your network. In this case, the voice and jitter were very good, and this was a good call. We can see things down below. And this is where you're drilling, and you're getting to a point where you could play this call back if you chose to.
Yeah.
Yes.
The 5 places in that example all require you to have a tap.
Well, yes, tap, and more nameless got an interface into one of their physical appliances or their virtual appliances. And that's the name of the game. These collector boxes only have so many interfaces, and they're very expensive. So what I've done with my packet flow switch is I have several routers stacked up going into one interface. So it's going to draw it like one place in your network, but really it's picking it up from several places in my network. You know, I'm on a poor man's budget on this project. So ideally, I have a lot of collectors with a lot of interfaces in every place in your network that matters, so that this graph looks correct and is true. So I'm struggling a little bit with that. Next slide here. This one we've used the QoS markings. Same thing. If you know where you're grabbing in your network, we use auto QoS with Cisco. Brenna does a lot of my switch deployments all over campus. We have golden configs. We try to turn on auto QoS at the edge switch, and in key places in the network, but often, not often, but sometimes that's missed. So here's an example where a call left our Aspen Hall with a QoS of 0, and then it came back from our library back to that call with a QoS of 46. So we have a QoS mismatch. And that led us into the switches in Aspen Hall, where we realized we had forgotten a marking statement on one of the trunks leaving Aspen Hall. So you guys all know that you can mark all this traffic all you want. It only matters during times of congestion. So the calls in and out of Aspen, no one was calling us, telling us they had poor quality, but you never know when the data network's gonna go crazy, and all of a sudden now you're starved for bandwidth, and now that marking's not there, you're not protecting that voice and video traffic. So doing your best to mark your traffic all through your network for voice and video is best practice, and this tool does a very good job of showing you, hey, right away, you got a QoS mismatch problem. So I use this every time we turn up a new building. I have this open immediately and see what's going on. So these are, I'm going to summarize here, these are our challenges in the last year. This project has shined the light that our Cisco Suite 2T engines are often dropping packets. When I take a look at the ports leaving the 2T environment, the Cisco environment, I'm seeing packet drops. We're sourcing spans of VLANs that have so much volume that the SOUP engine can barely keep up with doing its job, let alone doing all the spanning as well. And that's troublesome. So we need to rethink which VLANs we're spanning and why, and being smart about it at the source level. And obviously moving to taps helps you get away from spanning. In our data center, our switching fabric itself often has drops. Will and I've talked about this at length. When they move vMotion, a whole bunch of servers, that's massive bandwidth going across your network. And at times, the line cards and the chassis just cannot keep up with it. We're on a 5-year-old platform at this point. It's time for us to be thinking about our new data center and campus backbone platforms. Our appliance is getting overwhelmed. It can take in 1.2 million packets, Scott, but the 4 interfaces, 1.2 million, we're throwing so much at it, it can't even keep up on collecting it. So we're losing packets leaving our environment, we're losing packets coming into the collection environment, and so really that leads to problems. So really, we need to be smarter with our packet flow switch, we need to write smarter filters, and really get rid of this tool exhaustion, which is going on right now with us.
Can you discern, Chad, the difference between a lost packet because you didn't have sufficient capacity versus one that just got dropped in transit somewhere?
Good question. I don't know that I can answer. I just know that I can't even produce the packet data leaving on a span engine reliably, and then I can't even receive it reliably. So when you look at some of these statistics, your statistics are showing you massive packet loss that isn't there. It's a ghost. It's a weird problem that it took me a while to get my head around to realize what's going on.
So, I mean, unless you can capture all of it, can you even trust the data that you're getting? I mean, to analyze your call quality or anything?
No, I'm at a point now where I've realized I don't have good data. So yeah, this thing's going on red alerts and alarms that I've got packet loss and low loss scores, when really I don't. Yeah, that took a while to get my head around that. So those issues combined result in a false reporting of packet loss in MOS. That's my top point here. The situational analysis doesn't work reliably. During slow times of our network, when we're not spanning a lot of traffic, this stuff's right on. You load our campus up with a whole bunch of traffic, wireless, wired, internet, and now we're spanning all that and collecting all that, then the packet shows a massive packet loss. We're still moving those packets. To my best of my knowledge, it's not sort of critical point, otherwise my phone would be ringing. But for this type of analysis, it's not doing well. So we need a better instrumentation strategy at DU, and I'm aware of that. We need to come up with more taps, more packet flow switches, smarter filters. We need to invest. Filter rules need to be coordinated to get us there. Today at DU, we have a telecom network, operations and security, and no dedicated instrumentation team at DU. We have no FTEs named to that. It's Chad and one of Will's guys and a security guy. We all try to do this together as best we can. And often, we're not thinking about monitoring until after the project is complete and there's a performance problem. I would give you advice in this room, any new project you're doing with compute and storage, think about monitoring when you go and buy it up front. That's the time to be buying taps, buying licenses for monitoring, do whatever you're gonna do for monitoring. This was a marketing slide that I, again, wouldn't normally show, but it really kind of puts, I thought it was a good way to end this talk today. Your situational awareness of your network is important. You need to know your baselines. You need to know what's normal so that when things aren't working correctly, you can quickly see that non-normal behavior. And really, you know, today when an application isn't performing well, Will's team and my team, security, we're all over the place trying to figure out, or the DBAs or the web team, we're trying to quickly figure out, well, where is the problem and when did it start and what's going on? So the more you're thinking about that up front, the easier it is the day that arrives where you do have to troubleshoot that and deal with that. And so I just like some of the points that they have put here. You know, our war room at DU is often over email. Sometimes it's in a Zoom conference room. Sometimes it's face-to-face. But when we go into war room mode and have to fix something that's critical, it's a little haphazard. And I hope that we can mature our instrumentation strategy and our monitoring strategy so that it isn't so haphazard. That's a goal I've got. And I think Will and I are on the same page, and we can get our teams there with the many tools we have. I think that's it. Questions?
Were your soups giving you any type of messages that they were causing so much problem?
So our UC story doesn't really include students. If you think of
your supervisor and your soup to the T's.
Yes, no supervisors. Okay, what's the question?
Oh, were they giving you any type of warnings or errors or?
Oh yeah, we had high CPU frequently in our environment. We have EEM scripts on our SUP2Ts that collect a lot of data when a high CPU event occurs. And we take those logs, give them to Cisco, we look at it, and it is what it is. A lot of it's just sheer traffic. And then, of course, the span engine trying to keep up with that traffic to show it to us. You know, Cisco will say to you, only use span for troubleshooting. Okay, well, if your whole instrumentation strategy is built around that data coming in, I'm troubleshooting 24/7. It's on all the time. And I've had Cisco engineers go, who told you to turn that span engine on like that all the time? And I say, NetScout. And then they go, oh, well, you shouldn't do that. You should turn that off. Okay, so things we're looking at is span sessions that are just the VoIP stuff. I can protect that. But then I lose out on DNS performance, LDAP performance, AD performance, database performance, exchange performance, all the other things you care about from an application point of view, you give that up if you only span VoIP traffic. So, you know, these are some of the challenges I'm having now a year later, but I feel like we've made a lot of headway with this product, but we're not there yet. If anything, the NetScout takes a lot of care and feeding, some time and energy, some people really thinking about the problem that you're trying to solve. And I know there's lots of other packages out there. This is just one we had bought. We had an old Network General that became a NetScout. And so we're trying to roll with it. But it's an expensive toy, an expensive tool, and you need to stay on it, keep it current.
Todd, in the beginning you mentioned you're having trouble getting buy-in from new directors into this strategy. Like, why is that, and what are you doing about it? How are you helping?
Forever, NetScout's been seen as a network tool. Why would a database administrator care about a network tool if they have an Oracle tool that shows them logs, as one example? But packets are truth, everybody. They're the same truth. If you can gather information from the packets, it is what's occurring on your network, irrelevant of syslog data, irrelevant of transactional log data. So it isn't the all truth. There's still a need for a logarithm or a scene to have those logs collected and be able to be searched. This is not a replacement for that. It's just another set of data points. So I just had a couple directors and folks retire, resign, move on. And so the buy-in from all of us as directors isn't quite where I need it to be. I need to re-up my ante with Will and our peers and go, this is what we have, this is what I'm proposing we buy more of or do more of, so that we have a common set of tools to look at this information. And You guys know when you walk into a room with a new tool you want, the answer is no to begin with, without even looking at the tool, because we all have so many tools. And if you look at our budgets, what we've spent on the tools and the maintenance on the tools, there's a lot out there. And I'm not here to say other directors and their tools are bad or not good, but I believe in this story. I've seen the success of this in other customers, where it just saves your bacon quickly. I believe in the tool because I've seen its success. So really, I think they admitted at their annual conference, the biggest problem with their product is getting buy-in from the other areas of the IT silos. And we're trying to become less siloed at DU. It's hard, but we're trying to get there, where it doesn't matter if it's security, operations, telecom network. We're all at this together to solve these problems and fix applications. I didn't get into it here, but we've been fighting a health services performance problem with a health app. And we ended up picking up 2 of the virtual and finished streams to get right at the traffic. In this case, it's still remaining elusive as to where the problem is in our network. You get into these 3-tier architectures, sometimes 4-tier, with load balancers, firewalls, weird setups. It's difficult to determine quickly where's the problem that the user's experiencing this delay. And we're getting there.
You mentioned a poor man's budget. What's your budget for this stuff?
Well, really, we bought that packet flow switch 5 years ago. I'm out looking at new ones, and we're going to buy 2 of them, 1 for each data center instead of 1 in 1 data center. The NetScout purchase was expensive, the appliance was expensive, the UC license was expensive. The taps aren't bad, they're actually pretty cheap. So I don't really have a single number for you, Scott. We've incrementally spent money on instrumentation and monitoring over the years, but we've really never looked at it and compartmentalized it as such. It's always been piecemealing through projects.
So we found the same problem a number of years ago, spanning just, I mean, especially for our security practice, we had to tap instead of span because of these exact same challenges with CPU. But one question I had is, you mentioned that the taps are cheap, but from my perspective, the tap is useless unless you have something that can process the data.
You're right.
And especially as we're going to 100 gig speeds, the tap is still expensive in a sense. I mean, the cost of the optic to tap is maybe relatively cheap, but the reality is, unless it's got something that can process it.
You nailed it. You've got to land that tap on these packet flow switches or span switches, and usually with a transmit and receive, you have to burn up 2 ports here. That's expensive. Then once you do that, you've got to have a tool that's listening to it.
And processing at 100 gig speed now.
And so to process those types of speeds efficiently, quickly with these types of tools, you need to be smart and intelligent on your filter rule here on these packet flow switches, where you're only sending what you absolutely need onto the tool to avoid tool exhaustion. We were hitting tool exhaustion on dark trace. Do you need the full payload at a dark trace? No, because you're not looking at that. Do you need the full payload for UC monitoring to play a phone call back? Well, yeah. So that little jackknife ability is done through filter rules. And these products have come a long way, by the way, in 5 years. There's a lot of competition out here. And, people are pretty proud of the software that they've written onto these to do that. Deduplication, tool spanning, a lot of new feature names that come as license features in these switches to help you with this problem. And this is an instrumentation person's expertise.
You had another guiding principle you mentioned. Guiding principle, what was the last one you mentioned? The first one was tell you can't span with these buses.
Correct.
You said another one.
Packets of truth.
Packets are true. They are.
It's in my slide deck, right?
Is it? You can't lie with packet data. I can't tell you how many times I've gotten into arguments with application people. Well, no, it's doing this. And I'm going, actually, it's not. It's doing this. And I kick out a report out of Genius1 and a PDF, and I send it to them, and I say, open a case with your tab, because your software is telling you it's doing this. I'm telling you from packets, it's doing that. They're not the same. Trust me, there's something going on with your driver, with your app. I don't know what it is, but here, this is what's happening on the wire. And you often uncover bugs or problems, or the domain controller needs a reboot or something. There's something out there that the packet data will get you there. All right, passing the torch on.
So in my stream of consciousness, reminder, please send me your presentations. We'll get those all saved and linked. So if you can do that as soon as possible, then that'll correction. You do a job on the rest of this. I've added you. I just added, Kelly just asked me for someone.
But is it Google?
Yeah. So if you don't, if you didn't get, you got added after this last message. So we have a funny little system in Edinburgh where we add everyone in one database and then it copies over Google. So there's cowardly getting everything sorted out. So see a lag, but so did anybody else not get Alex's message he just sent about joining the? Do you want to be?
Yes, I have to this. That'd be great.
Can I also be added?
Sure. It's easy if you just drop me a quick email, it's marla@ucar.edu.
Yeah. Or you can laser point it.
All right, ready to go? Yeah, I'm Elliot Fedek, hello again, the University of Utah, and actually to dovetail off of the NetScout stuff, we have moved as well. There's some tool exhaustion that we have, so Jim's put us together like an enterprise architecture review. We're taking a holistic approach to monitoring and how we're targeting everything inside the environment. Everything from voice, which is lower on my radar because of the challenges you're seeing with the NetTap stuff, through the application stack, network performance, infrastructure performance, virtual hardware, all of that. So I know on the presentation it says that we're going to focus on SolarWinds. That'll be the core of it, but I kind of want to run through the whole stack of everything we're doing from a monitoring approach to gain this holistic view of what's happening in our network, in all our environments. So the two tools that we use core right now is we have a SolarWinds implementation and we have an Elastic Stack, formerly Elk Stack. You guys heard of that, familiar with that logging solution? It's a rival to Splunk for a whole lot less money. So in that, with the core tools we use for SolarWinds, we have web performance, server and application, network performance, and then the Elasticsearch for some of the logarithm stuff. We have some additional tools that does some device tracking where you can put in like a MAC address or an IP address. They'll tell you what port is plugged into in the network. We do some voice quality, very minimal. That's mostly handled by our Unified Communications team. Dave Packham, when he does his presentation, welcome to broadside, I'm sure questions on that. And then we have some additional tool sets to help our engineers rapidly troubleshoot any issues that we have. So to start with SolarWinds, with the server and application side, we do the nitty-gritty of everything that's happening on the server. We do monitor virtual infrastructures. We're heavy into VMware, so we're able to track when the server moves ESX hosts. Our whole approach from the enterprise monitoring team has been to augment the tools that the engineers already have. So we know inside of VMware, we know inside of Oracle that they already have some stuff that's giving them a deep dive and giving our engineers good insight into the performance of their systems. Our idea is to take that data and augment it and talk about scope and impact. So we can see when a server goes down, what ESX host it's on, and ideally trace that all the way out to the end user to tell you how many people it's affecting in what buildings and in what way. So now we move beyond just saying that, yes, this is an up or down incident, which historically I think what monitoring's been. Just a couple guys running inaugural shops, sending pages and spamming people. Now we're actually able to do some intelligent discussion and analytics, get our help desks involved. And in a couple instances, we've been able to contact clinics and customers before they've known that there's a problem to give them a heads up. If you log in, you're going to experience this issue. Give us a little bit, right? We're working on it. So with this type of stuff, we do CPU memory storage. We've started to do some initial forecasting. You'll find, Chad, that after you get after you get done with the tool exhaustion thing and you get buy-in for this, you're going to get so much data that we have, a ton of data, and now we almost need somebody to start to analyze this data. So we have some dedicated engineers who are able to help us build these tools, give our system administrators the ability to troubleshoot stuff. We don't have good data analytics, business intelligence behind putting all the pieces together. So I bet you that'll be your next pickup. So to start with, what I really wanted to focus on was the network performance piece. So we do as well the same type of thing. We do CPU memory and storage based on the network. We monitor all the ports. We can hit the VLANs. We do some interface details with this. We can do alerting as well. The SolarWinds mechanism behind the scenes does do some dependency analysis for you, where it'll say if you have an upstream device that goes down, everything downstream from this just goes into an unknown. Instead of spamming all the system administrators behind the scenes, you can just say, hey, your device is just unreachable, wait till this thing upstream comes upline, and then double check your system to make sure it all came back. It is dependency aware. However, we found as we implemented this tool that it's hit and miss. We get about 60% accuracy with the dependency all by itself. And then we have to have some sort of hands-on integration. People go in, actually set the rest of the dependencies or configure the rest of the dependencies. Out of the box, it has custom notification abilities. We're trying to take the approach of decentralizing as far as you making a request to the monitoring team and they'll set up your notifications. I'd like to get my engineers more involved, get their hands in the tools so they can rely on it, understand what the mechanism can do. So we've offloaded a lot of the alerting abilities to our operational centers and our engineers. They can do their own thing. So if you're getting spammed in the middle of the night and you don't like how that alert works, fine. You have the ability and the power to do that. Your operational center can change it. Your help desk can get in there. It's very GUIfied. SolarWinds has put in a lot of focus on GUIfying all these things. It's like the Microsoft approach, which has its pros and cons. You want to get in there and actually play with some of the command line stuff. There's some additional tweaking that you'll have to do. But we have found that the ability to do custom notifications and escalation policies has been extremely helpful. Plus, we just invested, we moved to ServiceNow for our service management platform. It does do integration with that. So it's been nice for us to be able to make dashboards inside of the ticketing system that Jim already has, where he's tracking performance. You can see anytime there's a massive tier 1 or tier 0 outage that's happened, and it'll follow along with what's happening. It's all been triggered out by the monitoring system. So up here you can see, this is just one of the dashboards that we have. On the left-hand panel, this is what the device tracker looks like. It's super hard to see, but you can, right here there's a host name, and then the IP address is associated with the host name, what type of device, its MAC address, and what VLAN it's plugged into. This has helped a lot of times when we know that there's an issue on the network that we can search, or if you're missing a device, you can search by MAC address, see what port it's plugged to, and trace it. And on the right-hand side, this is some high-level packet analysis. This by no means, I think, replaces what's happening with NetScout or anything like scrutinize or release type of tools. This is more just to give you a high-level overview of what's happening to and from. Our security team has loved to use this because it's all the data is in one place. They can come, they can look, they can say, hey, this looks anomalous. And then from there, you drill into the more deep dive tool. The network team can take it over and see what's happening on a packet-by-packet analysis. We've recently taken all this data. SolarWinds gives you the option to custom tag any of the devices that are inside the system. So we tweaked that a little bit. We custom tag things by our building number and building names. And then it's got a Microsoft SQL backend, which plugs in nicely with our ArcGIS backend, which is also Microsoft SQL. So we can track on a map the status of any building network on our campus. So anytime we have a device that goes down, because of its tagging, the network team keeps on top of the tagging of knowing where the device is and it's not. Once it goes down or is impacted, instantly we have a dashboard on our Maps interface that will turn it colors, like this one right here has turned blue because there's work going on in that building. It'll go red if there's something full on down. This again helped us troubleshoot. The idea is to get on top of things, or get on top of things as fast as we can to get to resolution as quickly as possible. So we're able to see from a visual perspective when things are up and down. They put this stuff on the dashboards at our operations center as well. In our network team, they have these hanging out. Jim's got one sitting right in here. I hope it's still up. Yeah, okay. He's got one sitting in his office, so everybody knows when one of these buildings goes red, the CTO will come saunter around the corner and bug somebody on, hey, why is this down? What's happening? So it gets a lot of eyes. Everybody understands what's happening with the network. We're able to communicate quickly and effectively on when there's an issue. And at any time, if you guys want to stop me, let me know. Just kind of breezing through this. They just released with their latest version, SolarWinds, a network pathways. It's called a net path analysis. What this does is you can put in any host IP or any destination IP and port, and it does like a glorified trace route, where it does as many trace routes in a consecutive manner. We did this with BYU a while ago, and we're able to see into their load balancer and all the stuff behind it. In fact, no, that's not the one. Oh, this might be the one. Is that going to you guys? Yeah. Oh, yeah. Yeah, that's us. I should have pulled it. I forgot you guys were going to be here. I should have pulled that. But what this does is we have our polling engines. If we go back to the first slide, we have 4 core polling engines, 3 that sit on campus, 1 that sits in our hospital infrastructure. Because of data compliance, we've had to keep those 2 things separate. But we can initiate a pathway from either of those things, and it doesn't require a lot. You just give it a URL and a port, and it does this type of path analysis, where it consecutively does a whole lot of trace routes and tells you the latency between, the packet losses between, and one of the IP addresses. It doesn't data, so you get the who is information, if that's accurate, but it'll give you the who is information alongside this. So you can see the path that you may take to get to, this one is Canvas. So this is our institutional learning platform, our online learning platform. We've hosted it in AWS. So you can see what the path is taking to get there. If there's an issue, since we also have the configuration management module in SolarWinds, if there is an issue and you have a route that drops, it will instantly look at all the changes that have happened for our configuration management tool, and if it notices that something else changed within 5 minutes of that packet dropping or that path dropping, it'll do a diff on this screen for your engineers. So you could float over it and it would say, hey, it worked before when this was the configuration, it doesn't work now, here's the new configuration. It's a good place to start, at least starting to troubleshoot stuff while everybody else is running around with their hair on fire.
Elliot?
Yes.
So just Canvas is a great example of the value this tool has brought. Some of you probably also use Canvas, and you'll start having a problem with Canvas on your campus. This tool has shown us that half of AWS went AWOL, and it actually goes red. And we can show that we're green up until we get to AWS. And so, and it does it in quasi real time. We know it as soon as our students know it or before. And so it really, from the cloud hosted services perspective, having this tool that Elliot's deployed has been, I mean, we have our athletics ticketing solution. I can't count the value of the data it's provided in giving it back to them and saying, look, latencies all of a sudden go crazy once you get to this hop at this place, clear out and who knows where, and everything else is fine. And it's been valuable.
We found an issue with, we use Box.com, and we found an issue a while back where our net path analysis was showing after we passed out of I2, so we got out of our infrastructure, out of our data center into I2, it was forking data off, it was like null routing, off to somewhere random. And it would say, hey, this is a red box, I don't know where this is going. And instead of us internally escalating tickets with the UC team to say, hey, fix your stuff, we know that it's not internal. We can start to talk to Box and ask them what was going on. And that was back when we had the big DNS issue. Was that like in November? Do you remember? When was it? Do you remember that was, Trevor? They were doing, you're talking about?
Yeah, it was last fall.
Last fall. The what?
The dying problem.
Yes.
Yeah.
It's
like November.
So we were able to see quickly that, hey, this isn't an us issue, and start to help pinpoint what's going on. What's nice about this is one of the more valuable tools inside of SolarWinds and one of the least expensive tools inside of SolarWinds. There's 2 tools that I'll highlight as we move through this that aren't pitched. I don't want to go into all the details of the server and application storage monitoring stuff. You guys can go to the vendor and they'll give you way better pitch than I do. That's what they're trained to do. But I will show you the tools that we have found more valuable for us that aren't necessarily out of the box highlighted by them. This being a new one, they haven't pitched it very hard yet, but we found lots of use cases for this. We also take and deploy Mac minis. We have little Mac minis that we deploy in all of our buildings. We've got 48 of a couple hundred buildings, so not all. We're working on it. Jim will budget this by the end of it. So we deploy these out to like the most of our buildings on campus, and we're able to do network paths between our core data center and these Mac minis. So now we can see, because we're a distributed campus, we can see when there's like a fiber cut, when there's a network break, when there's any issues that are between our data center and that, or if the issue does actually lie inside of our network that we can control. So we've started to use this network path to kind of analyze that, and it comes full force with like the smallest implementation of the network performance module. So you don't have to go get the giant unlimited license to get this. I imagine once word gets out the value of the network performance stuff, that may change, but as we said, it's been extremely valuable and not as expensive. Speaking of those Mac minis aren't just endpoints for us to do network paths in and out of. Yes.
Sorry, on the pathways, is that part of the new version upgrade?
Yes,
Or is that a mod you have to add on?
It's part of NPM 12. So if you get the network performance module, it's in it with version 12. So those Mac minis that we stick out there are not just good for endpoints for us to do these transactions and see the trace routes between. We use those as well to log in and out of our tier 1 applications and a whole bunch of applications around campus. So those Mac minis are like we have a Selenium script. If you guys are familiar with Selenium, it's similar to that, where it has a little recorder that we can step through, logging into Canvas, clicking on a course, logging out of Canvas. Our QA team with our programming and development shop has started to take advantage of this, and they're watching the speeds and how their application performs. It stacks the performance against all the other locations. So if you have one Mac mini that's slower than all the other Mac minis, you don't have to have the help desk open up a ticket with the development team to say, hey, your application is slow. We know we can target just the network in that arena. Or say at 6 a.m., every transaction from all 40 locations cut slow at the same time for the same amount, and they call the help desk and they start to complain about the network. That might not be the network. I would maybe start and ask, was there a configuration change? Do we push a new type of program out that may have caused that latency with your release window? So those are doing that. They stacked, like I said, here you can see one where they stacked all the locations on top of each other. That's pretty common. You see it pretty solid like this. You can also have it show dependencies on any applications behind the scenes. So if it requires like a JBoss to be running in order for it to function, this will say if that JBoss is up or down. So if you start to have issues, you say, hey, you're having issues, but that might be because this application is down on one of your cluster servers on the back end. That's another good place to start. We do record screenshots as well with, I came up kind of operationally focused, so this is sounding like an operational pitch a little bit, that's why. I wanted to help the help desk as well communicate out to our end users when there's an issue. So anytime that there's an error, it records the last 10 screen grabs of that error. So no more getting a call from a doctor or a professor or a student saying, hey, I'm getting an error, and then you have to take 20 minutes to say, well, what's the error? And it says, well, it says this is Windows Explorer. You go, okay, what's next? Well, there's an address bar. No, further down. Like, you don't have to go through that anymore. We have screen grabs that will show if it's a 400, 500, 404. What type of error is your end user getting? Is it an authentication error? What's the issue? Recently, we had some challenges with an LDAP syncing, and we're able to see our user logged in that we used, and it was showing an LDAP error, and we're able to troubleshoot it and get it fixed quickly before our end users knew what was happening. This is another one of the underutilized, I think, tools inside of SolarWinds. It's less expensive as well. A little bit more. We bought the unlimited one for this because we have all of our applications that run through this. It's something like 200 and some odd different applications from 40 locations. If you do the math, that's a lot of times that we're hitting it ourselves. Some things that you want to keep in mind if you implement something like this to not denial of service attack yourself. Like, don't have, we log in at about 5-minute intervals. When we very first deployed this out to 40 locations, we were doing 5-minute intervals, hitting our central authentication system, over 200 applications. It was, yeah, we got, sorry. we got in trouble a little bit by hitting our system too hard. So we've taken a re-architecture approach where we have 3 core locations that run all of our transactions that are constantly logging in. We do it in the sake of the same type of thing with publications, that if all 3 are down, odds are something is actually down. If just 1 is down and 2 are up, we should probably look at this a little bit deeper. And then only our really high level applications that we log in from every location around the campus. Any questions on these? If you're a developer, it's nice, it pulls TCP charts as well. It does a whole dump of that. So if you have an issue, it'll show you in your developer graph what call has been the longest. When we very first implemented this, we were logging in and out of the library. Is anybody here from the library? Our library. We were logging in and out of our library webpage, and the help desk was already getting calls about it being slow. And when we turned it on, we found that they had an uncompressed 2 gigabyte icon that they were trying to load on their webpage, and that was causing all the latency. It was downloading 2 gigs of a little black and white skull. We're able to ideally point this out to the developers. They go, oh yeah, we forgot to compress that, and then their webpage goes fast again. So this has been another one of the tools that has been extremely valuable, and I think that helped the network troubleshoot what's happening. If you couple this data, so these Mac Minis are running the end user transactions we're logging in and out, plus the NetPath data that's going from our data center to the Mac Minis, we're able to, again, really kind of articulate what's happening on the network. If we lose an entire Mac Mini, we know we can look at the NetPath data and see where the issue is. Was there a configuration change? Is there a break in one of our fiber lines because somebody's done construction somewhere? We can rapidly troubleshoot that. From here, we have a few additional tools that we've leveraged out of SolarWinds. Again, we have the device tracker where we're able to put in MAC addresses and IP addresses, and they tell us what port that it's been in. They've had challenges. SolarWinds does have challenges if you use this. In doing multiple perfs. We're engaged with them and we're trying to help them try to navigate this issue. For the most part, they can do 1 and 2 perfs really well, but if you get beyond that, you're gonna start missing data. You'll get the IP address and you won't get the MAC address, or vice versa will happen. So if you're interested in this and taking a dive at this, I'm happy to talk more about it and keep you posted on when this issue is resolved. We also have a tool set, which is nice for your tier 1, tier 2 network engineers who are just coming up and haven't learned all the command line skills yet. Like these are Google-fied interfaces that they can do all like the trace routing, packet analysis. You can target some net flow information at a high level, and it helps those engineers kind of come along and get more involved with the deeper tool set. Like I was saying, we do some configuration management with this as well, where we're reading a log or sending SolarWinds log information. It doesn't hold it for very long, but as soon as it gets the information that there's been a configuration change, it copies it and archives it. And then we have about, I think it's a year's worth of archive data for all of our switches. So if we ever have something we have to go back to, you don't have to go from memory and rewrite it, we can go pull it. They just as well, we haven't had a chance to play with this, but they released like a multi-level analysis tool where you can stack all these different components on top of each other and see what's happening. This is us with our time management system that we've had to reboot on a nightly basis. And you can see these reboots happening right here, as well as the end user performance impact and the network analysis in and out of those servers. So the idea is, now we've moved past the toolset team and the issue of getting resources to manage the toolset. I think this is the next phase of monitoring, is getting into actually doing business intelligence and getting some data science behind your information. Because you'll find you're going to get so much information that's coming in through these things that it's hard to stay on top of and understand the entire scope of everything. You have engineers who are busy making sure that the system's running right, parsing logs, configuring data. What you're missing is really the ability to put it all together and to start to do analysis and forecasting and tracking and get ahead of these problems. And that's kind of our next phase of this institution that we're moving into. And to help with that, we have an elastic stack that we picked up, which has been amazing. It's been awesome. We're able to geolocate, do some filtering, log searching. And again, this is a good tool for us to start to dive into what's happening after the issues already arisen. BYU helped us out with our implementation of this. We're a little bit behind where they're at. They've been hugely helpful, and we found it extremely valuable in starting to do some of this data mining, business intelligence, and visualization of what's actually occurring in our entire infrastructure. And that's the idea, is you want to get to some problem forecasting. And then you can actually start to have some data-driven decisions for your implementation of your institution. Does anybody have questions? That's it. I have more, but I think we'll be out of time. Yes?
Are you able to keep up with your AUX stack? I mean, we find we have to have a lot of CPU and disk powers.
Yeah, we are. We scoped it. Luckily we had some guidance from BYU who we learned some lessons from. So we scoped it off the gate pretty well. We sat down with them and talked, and we purchased the gold tier as well, so we could do some redaction out off the bat and not have to engineer a solution over the top of that. But we have, we bought the 40 node license. So we have pretty beefy, and ours is all virtualized as well, so we're running it all on VMware. Any other questions? No? All right, that's it.
Thanks much, Elliot.
Thank you.
Thank you.
This is your agenda adjustment.
Oh, now we've got the mirror in a mirror. When do we want to take breaks?
But of course, you can always take a break.
No, what'd you put in there? Utah Saints?
Yeah. Like that? It's had virus on it.
No.
Is that it? How do you use this crazy?
And speaking of the break, Dave is going to do a drone photo, so I think you would just walk straight out this door. Yeah, no photo.
That should work.
Okay. Sure.
Does it work?
Yeah, works good. So I guess we're ready, right?
Go for it.
Okay, so first of all, anybody use ACI in their environment? Define it.
Cisco ACI.
Cisco ACI, yeah, so application, that's their SDN solution for the campus, for the data center network. Anybody use any SDN solutions in the data center? No, not yet? Okay, well, that's probably a good time to talk about it then. So, so we're using Cisco ACI, or we're just about to start implementing it. What that consists of is it's a software-defined networking solution, and we have it's controller-based. So unlike your traditionally managed switches, you have to manage all of the switches. Like we have like 80 switches in our data center today. So we have to log into every single switch and make changes. Add a VLAN here, add access list, security policies. That's all done in this environment by these 3 API controllers. All the configuration is done on that. So in our environment, we have, it's called 2 spines, and we have these leaf switches. We have 80 leaf switches that connect back to each of the spines. So spines don't connect to spines, and leaves don't connect to leaves. So each one of the leaf switches connect back to the spine switches, and that's what builds an actual fabric. And it's really a virtual network that's built on top of a physical network. And what a fabric really is it's an underlay and an overlay. And the underlay is more of a traditional network, where these just have layer 3 routing between all the networks. We don't actually manually build that. The API controllers and the ACI fabric actually builds that when you plug everything in. And then the overlay is a protocol you use VXLAN. And what that basically does is build tunnels between all the leaf switches and the controllers. And that allows you to do stuff like what VM typically does. Allows that virtualization of the network and allows you to do things easier and simpler. And then one of the requirements for SDN is to keep the control plane and the data plane separate. And the control plane is where you make your routing and configuration changes. Another benefit is routing is done on the leaf switches. And that's these switches on the bottom here. Today in your environment, maybe you have 2 core routers in your data center and a bunch of edge switches in your data center. Typically, the routing is done on your core switches, and you have a server that's connected here. If traffic was going to go between, on the same edge switch, between 2 different servers on that same edge switch, but have to go back up to the core and then back down to the leaf or to the edge switch. Today, in this environment, even if they have to go between 2 different VLANs, that all would stay within the same switch. So it really reduces the traffic that it goes across your core of your data center network, which is between the leaves and the spines. Our environment has 40 gig links between the leaf switches and the spine switches to handle layer 2 as well as layer 3. Another great benefit is, by default, your layer 2 flooding is disabled. There's no spanning tree in this environment. As your network engineer, that's probably what the thing you hate the worst, is spanning tree. Spanning tree can take down your entire environment. Any questions?
Yes, sorry.
Yeah, Alan?
You said that you could route on your,
These switches?
Yes.
Yes.
Between 2 subnets on there, would you do inspection there as well?
What type of inspection?
Like equivalent to what your firewall between 2 subnets, if you wanted to only allow certain things between these 2, would you have to route that up to some kind of firewall device, or is that a virtual something that's sitting on the edge?
So if you do, yeah, so what you can do is a couple things built into that. That's a great question. One is, you'll see when we get done a couple slides how the security policies are enforced in here. But there's also something where you can actually copy the packet from here to someplace else. So if you did want to look at some specific traffic, you can copy that traffic and then send it to another device for additional monitoring. So
I was thinking more firewall, less just monitoring. So
yes, so firewall, if you have a physical firewall in place, yes, you absolutely have to send the traffic from this device back to the firewall. So that's where you want to strategically figure out where you want to have the firewall. And that's part of ACI too. You can have a service insertion where you can decide where you want to put it. And then you can decide which types of traffic. In our solution, we're probably going to do a lot of all north to south traffic. We'd be firewalled. We got some Palo firewalls that we're getting for the data center, as well as some of the stuff east to west. But most of the east to west traffic will be controlled by the ACI contracts. So yeah, this is the slide here that talks about the contracts. ACI is really focused around application. It's getting away from this very network-centric mode, and it's really focusing around applications. So the components of that is the tenant. The tenant, in our case, we have 2 main tenants. That's kind of your business unit, perhaps. You can view it in different ways, but we have one for campus and one for clinical, and we have one just for testing purposes. And then the next component is your application profile, application network profile. And that's where you can group your applications, your various types of applications. And then within your applications, you have EPGs, which is stands for endpoint groups. You can also consider that a security zone as well. And that's where between the different EPGs, you have contracts, which are your security policies. And that's built into, it's a little bit different than access list. You actually build those policies in your controller. And you define, and you can reuse contracts. This contract it's probably not, but could be the same as this one. So you can reuse contracts, and within contracts you have filters, and you can reuse filters. So this kind of uses an object-oriented approach. The idea is to reuse as much of these components as you can. And one of the big things with ACI is, I kind of forgot to mention earlier, is the idea is not for the network team to use the CLI and type all this stuff in. You do have a GUI interface, but again, it's even not, the approach is not necessarily even to use the GUI. Obviously, we're going to have to do it occasionally, but a lot of it is to try to get a whole workflow automated. From the time a server gets provisioned to the time the server comes online. That perhaps includes the building the virtual machine, the storage, and then this is specifically the network component of that. And so there's a bunch of, the whole ACI infrastructure is all API driven, all RESTful APIs. You can use whatever programming language you want. Typically it's done in Python. And it just allows for that automation use. Okay, so the contracts, the initial contracts we talked about, and then the bridge domains. That's kind of like the VLAN or the routing for your network. And I'll show you, like in the next slide, I think that's probably, I think it's the next slide here, how that works. So you notice here's the EPG, which is what I said was like a security zone. You notice here, if these were /24 networks, these are two different subnets. These two different subnets can be in the same security zone. In the past, you would have a security zone equal subnet. Well, we don't have that limitation now. We can have these two subnets within the same security, or two different subnets in the same security zone. You can have, you notice this IP address and this IP address is also in, is two different security zones in the same subnet. So we can also split that apart as well. So we can break that down, and now we can group servers in security zones, what makes sense. They do have to be in the same bridge domain. That is one of the key things you have, it has to happen. Okay, this is, I just talked about this a minute ago, is the open APIs. The all REST calls, all the APIs are published on Cisco's website, developer.cisco.com. And they have a lot of integration into existing tools. VMware, vCenter is one of the biggest pieces. We're a VMware shop. VMware directly ties into ACI. So for the VMware admin, they can choose what endpoint group they want their server to be in. So from the vCenter, they can say, when they set up the network profile, they can select which EPG that this server should be done, as well as by automation tools as well. Hyper-V is also supported, Docker containers they're working on. Most of the firewall vendors have integration into it as well. Load balancers. We also did the Clicker, Cisco Cloud Center has integration into it. We actually just did a hybrid cloud initiative tool, and then the HP Orchestration Center also integrates into this as well. ServiceNow has a really nice plugin to this, as well as Infoblox, or and a lot of it, and we're even writing some of our own tools. And that can all be done by REST APIs.
Tim, just
Yes.
one second. So I don't know if you guys have had the same problem that we've had, but with our large VMware farms, and to do auto provisioning or high speed provisioning, so to speak, we've ended up having to terminate all of our VLANs on our VMware enclosures just because we never knew which VLAN a particular server would need. And that has, you know, obvious implications for management when you have hundreds of VLANs terminated on hundreds of ESX hosts that are essentially our large VMware clusters. This solution, as we move to it, I think if you caught in the, you know, in kind of in between in there, that an actual VMware server administrator now has the opportunity with the integration to pick what network it's going to be on, and as a result, the VMware environment will be much simpler because the network now is in essence VMware aware. And so as servers deploy, the environment will essentially respond to the server rather than us having to have this huge surface area of VLANs deployed to every single ESX cluster.
Yeah, good point. Yes?
Could you just tell us a little bit more about the ServiceNow integration? I know you're saying you're just getting started with this.
We haven't actually, so the ServiceNow integration is, since it has, I believe there is a plugin into ACI, as well into Cisco Cloud Center, which is, we decided not to go with that solution, but there's an integration into the HP Orchestration Center as well, which allows us to actually build. So the idea is with ServiceNow is we would like to have customers come in and build like a virtual machine for like a web app, for example. That would be done through ServiceNow. They can fill out the form. The VM gets deployed, as well as the network components would get deployed. And that ServiceNow would be there. And I believe you can also you can use ServiceNow for basically the database for all your inventory and stuff like that. CMDB, that's the word I was looking for, CMDB.
So you guys are going to do that?
We're going to start down the path and get tying all that stuff together.
The long-term plan is to have, in essence, a real private cloud. We've promised that to our customers for a long time, but the real goal, and Jim, our CTO, who's joined us today, he's been a key driver behind that to help us get that accomplished. And that is our goal, so that our customers can come in and they can essentially say, I need a host that does this, and has this operating system with this many resources, and within 5 or 10 minutes, they get an email back, saying it's provisioned for you, and it's working on this network, right? And the real excitement of this with Jim's support is through, we're calling it our hybrid cloud initiative. Our goal is so that we can expand workloads both in or out of our own data center, so that our customers don't need to know where that workload is actually running. It will depend on what their needs are and where it's cheapest for us to run that workload. And those kinds of things. Long term, that's the vision. Right now, it's Jim, do you want to add to that?
Yeah, it's basically delivering that Amazon type service to our customers for our services.
And I think and on the server side, I think a lot of that was already there with VM. You can do some of that automation before. The network is just finally getting there, right? Is where we can start automating some of those tasks. So instead of the networking team or the customer waiting for this service order to go through the multiple teams, it goes through ServiceNow, request it, like Mike said, maybe a few minutes later, they get it done. There's all this ticket transaction work, which could take weeks sometimes. It can happen in minutes, perhaps.
Is it smart enough to look at info blocks to see which subnet's available and then assign that?
Yeah, so ACI in itself doesn't do that, but your orchestration tool will. So either that's Cisco Cloud Center or the HP Orchestration. We decided to go with the HP Orchestration Center. And you have to model that and build that in the tool. But once you build that, yes, that was one of our demos that we did in the Hybrid Cloud Initiative. Was to actually go into Infoblox, get an IP address out of that subnet, and then assign that to a server, and then that server gets applied to an endpoint group. So we've demonstrated that we can do that with this hybrid cloud tool. So why did we choose ACI? There's other solutions like VMware NSX, which works great if you're mostly VMware based, which a lot of people are. But we have a mixture of Citrix, Zen, and then VMware. We've got bare metals, storage devices. So we can apply these same security policies regardless if it's VMware or not. Hyper-V, we got a little bit of Hyper-V.
We have Oracle's
virtual machine
as well for the Oracle environment.
So that's probably one of the biggest reasons we chose that. So another thing too is this tool we're going to do things a little different than we have in the past. Typically, the network team keeps their tools and stuff to the network team. We want to share this tool with the other teams So they can help. They can also look into the tools. This is like health scores. Remember I talked about this application network profile? Within that, there's a health score. It says, oh, drop down to 80% for this application. Now you can dig in as the application owner or the system admin and say, oh, the reason that's happening is because we're getting interface errors on this port. And then you can contact the network team or whatnot. And again, it integrates into VMware and they can auto-provision the servers as long as the EPG is created already. Like I said, the fabric, when we deploy the fabric, it comes up pretty quick. Once you get the fiber and the copper infrastructure in place, you just plug in the cables, you go to the 8-bit controllers, and you have to configure a few things, and then the fabric comes up. If you were to do that on 80 switches manually, that would take probably a long time. We're hoping this is going to reduce tasks because we don't have to make changes on every single switch. We apply it once on the 8-bit controller, and it can be applied to all the switches. I talked about that. It also supports the microsegmentation, where we can break down. We don't have to apply a security policy to just a VLAN. We can apply it to a subset of a VLAN or a subnet. And we talked about that as well. Just want to spend a few minutes on our migration strategy. If somebody else is, if other people are thinking of how to get from where you are today to the ACI environment, this is the way we've done it. There's other ways to do it as well, or the way we're thinking of doing it. So basically, this is a simple diagram of kind of what our existing network looks like. Our existing network is the MPLS backbone, ties into our data center, and this is our new ACI. Remember I talked about the 2 spine switches, and we have, like I said, 80 leaf switches. So we're in the core links, since these guys don't actually do routing, nothing actually connects to the spine switches other than leaf switches. So these 2 leaf switches connect back to the core routers here, which has all the MPLS, all the VRFs. We're going to tie those in together, and we'll be passing layer 2 and layer 3 between these 2 environments. At that point, we can begin the process of moving the routing from here down to these leaf switches, as well as we can start moving the routing from here to there. And I'll show you the next slide. This is basically our approach. So where I had that slide up there earlier, where we talked about the endpoint groups and application profiles, that's the pure application-centric mode. And in order to get into that, you really need to understand how the applications work in your environment. We don't have a good, that's one of our challenges, we don't have a good understanding of what the security policies between all the applications are. So the first phase is going to be what Cisco calls a network-centric migration. Whatever the existing policies are, that's what we're going to do. We're going to migrate that to the new environment. So basically, this means moving all the servers physically from the old switches to the new switches is essentially what we're doing. Integrating VMware's vCenter into it. We'll have the ability to any new applications that come on board to get that set up into a pure application-centric mode. We're taking this opportunity to go through the network as we can and try to clean up some of the configurations. The second part is where we really begin to get a lot of the benefit to this, is the security zones. And we're going to get this tool, Cisco Filtration. So it's a tool that there's agents that sit on the switches, as well as agents that get deployed on the servers. And they can monitor all the traffic that comes between applications, and we'll start identifying the workflow or the flows, network flows between the servers, and actually recommending security policies and how you group the servers together that make it EPG.
So
yes.
just 1 second, Tim. So just to reemphasize, our initial 12-month implementation, the first 12 months is essentially replacing some legacy, well, not legacy, just some aging hardware in our data center. we have to get that retired. And this ACI infrastructure is actually cheaper for us than replacing it with the traditional legacy topology, the traditional Cisco topology. And so this first 12 months is essentially getting the hardware replaced. We aren't going to be using the significant advances of contracts and the really micro segmentation that this platform will offer us. But the goal is, once we get moved and with tetration, we can then, for the following year, start working towards the segmentation and the security zones that the platform enables for us.
Absolutely. Okay, so gotta speed it up a little bit. So basically the server migrations, we've come up with a couple plans. One is we have like a HP enclosure here. This is we have 2 connections here today. We can add this additional network ports on the servers today. We can add 2 new ones. And then we make sure the configurations match the configurations over here. And then the server admin doing a change window would just shut these off, turn these on. And we were able to do that with less than like a second of downtime when we did that. So that's one approach. The other approach we're also using is if the chassis or servers are completely VM, we can vMotion the servers off this device onto a new device, and then reconnect that up, test it, and then vMotion it back. So we've got different approaches of how we would actually do that. Any questions on the ACI before we move to campus SDN? Yes.
How many staff members do you have on your orchestration team for managing the ACI and building the ACI?
We have, what, for network, how many people do we have in network? 18, 20?
So we're saying the whole network team's doing it?
Well, so
I just mean the orchestration team that's focused on ACI.
Okay, so ACI, we have 3 people leading that initiative right now in our team. We also, and we're going to bring on, when we go operational, another 4 people. And I think we have a total of like 20 people in the network team altogether.
So the whole network team will have some training on this, but there's a group that does service now, which I don't remember how many's on that team.
Yeah.
But the network group will be totally cross-trained, how to help and troubleshoot with it. But yeah, we won't necessarily have our hands on the service now piece, but we do have a couple engineers who are pretty well versed with some Python scripting, and they'll have to help with the workflow.
Sure.
Okay. I think important to Tim's presentation is that all the other teams are going to have to be really heavily invested. There's no way the network engineers can come on and say, hey, okay, we're getting ready to go.
Yeah.
The app owners have got to be involved.
Yeah, and a big part of the orchestration is Jim's team. We have the server team. They are going to be the lead team to set up the orchestration, where they're going to be building the HP orchestration center, the VM integration, server integration tools. So I think with the other Jim's team, they got a team. I don't know how many people on work that, but so they're going to be the lead. I mean, they're going to be working with us. I mean, I think this whole SDN, and you could say virtualization, is really needs to bring the teams together instead of all these silos, having the teams work together better. I think that's the key to this whole thing, in order to make it useful, right?
Tim, I had a technical question.
Yes.
Back on your diagram showing the one back right there.
Yeah.
So the data center firewalls in the upper left, are those the the Palo Altos you mentioned?
Those are the Junipers right now.
Okay.
So that's the existing. I think in July, August, September, new fiscal year, we're going to get some Palo Altos. Those will actually be deployed right here, connected directly to the leaf switches. And these,
you'll maintain both for a period of time?
Well, yeah, for a short period of time. We'll migrate all the firewalls from here down to these.
Okay.
To these new
and so you'll have these dual firewalls, physicals, that'll plug into leafs with some sort of redundancy to 2 leafs?
Absolutely, yeah.
Okay.
And as part of that environment, all of these are leaf switches. We kind of designated 2 of the leaf switches as leaf services switches or leaf border switches. And these switches essentially connect to the border outside of the fabric, as well as connect to like firewalls, load balancers, other types of network services functions.
That would be an interesting diagram to see at next WestNet how that looks. And I'd be curious how well the ACI software plays with the Palo Altos, and if they're getting along, you know, how that's going, because they're probably going to be right behind you at some point.
Okay, cool. Yeah, sure.
Can you cluster those Palo Altos?
I think by default they're going to be. You mean clustered like to add additional resources?
Just
cluster
so there's cluster them for redundancy.
Yeah, I think that's the typical deployment we have. Okay. They're clustered together.
But if you make an error on one, all of them get the error, right? Your whole network goes down, right? You cluster.
Yeah, that's.
No, that's bad.
Yeah, it's bad.
That's what it's called, the cluster.
So campus and SDN, maybe I'll spend the next five minutes and go through this real quick. So what's some of the challenges we face in the campus network today? I kind of listed out a few, there's probably a lot more. As far as networking, we don't really like stretching or spanning VLANs or all through the entire campus. That can cause disaster. One guy hooks up one server wrong, spanning tree loop takes down one building, one node, one campus. So that's an issue. We know we have end users and departments that really would like to have the same subnet in multiple buildings, the same security zone perhaps in multiple buildings. Basically, this is ACI for the campus in a way. This is stuff we're looking at right now. There's network segmentation, not really a great way to do that today. Again, we can do it the way we always have in the past. Create a subnet, apply the firewall or the access list policies to that subnet. Role-based access control, another issue. Again, it's similar to ACI. Today, we have over 200 buildings, 5,000 switches, 50,000 ports. So there's a lot of configuration we have to do to bring up a network or bring up a network in a building. There's a lot of ports we have to tie VLANs. Every time somebody moves, we got to go and log into that switch and put a new VLAN on, a new configuration for those ports. A little joke here is there must be an easier way to do this, right? You think, right? So let's see if that is. So host mobility, this basically describes here how this works. So you can see here, we have 2 routers here across your IP core of your backbone. And you notice we have this 10.1.0.1 and 10.1.0.1. So really, we can have the same subnet, or this host can actually move. In wireless, that already works, right? In wired, that's not the case. We can't, well, you can do it if you want to span the VLAN, but everyone doesn't span VLANs across the campus for the reason of taking down the entire environment. In this solution, you don't actually span VLANs. What we do is we separate the location, which is your IP address. That's what the whole point of IP address is, to determine how you get to that location from your identity. So we really want to separate the identity from the location. And like I was talking about on the ACI, now we can have these anycast gateways. So every single switch in your environment can be a anycast gateway, meaning every switch can be the router for that interface. You don't have to send everything back to a distribution node or campus or campus core. So network segmentations, kind of like what we talked about with the EPGs. There's also, on the campus fabric, you also have the ability to build campus policies. And that is basically, you can kind of, this is a snapshot of Cisco's little diagram. You can have your different security zones here, and then you define what the policies are between each of the security zones. And then you can apply the security policies between that at any layer, and those policies would be applied at the edge instead of sending everything back to some distribution point. Those policies can be enforced at that point. Running out of time here, let me skip through here just to talk about some of the basic components. We have the basic components. We have a fabric control node, which is basically a list server. It is a Cisco switch or router. And then we have these fabric nodes, which are just your 3650s, 3850s edge switches. They act as the fabric edge node. And then you may have your traditional underlay switches or your distribution routers. Those are just your underlay, basic IP connectivity. And this is your overlay, like we talked about in the ACI, which sits on top of the physical infrastructure in the physical routing platform and provides this virtual network. And then we have the ability to, the goal is really to have someone log into, when they come on board, instead of having like VLAN 500 set up on that port, they log into their network port, kind of like they do in wireless today. Once they log in, they will get their VLAN about 802.1x or some other mechanism will provide them the appropriate VLAN and security zone, and they're onto the network. Let me see if the next slide here. Let's talk about that. Yeah, and one of the other goals, and I'll talk on the next slide too, is we'd like to get away from configuring, like I said, we have 5,000 switches. We really don't want to deploy 5,000, keep deploying, we have a lifecycle replacement. We'd like to get away from manually provisioning switch by switch. So there's a way where we can auto-deploy the switch, but in order to auto-deploy switches, we have to build standardized config templates. And that's where, instead of saying, this guy's on VLAN 50, this guy's on 55, VLAN 55, that's determined by the login authentication. So basically, all the ports on the network would be all 802.1x ports. And then we don't have to manually have separate configs for every single port. And then we standardize the config. We can have a tool that they can do some pre-provisioning of the switch. Someone goes out, racks the switch, it talks back to the controller, grabs the config, switch is done, deployed. So that's as well as the config. And we can have the security zones and the same IP addresses. People can move wherever they want. So how does this work? Up here we talked about the fabric control node, which is the list server. This kind of works very similar to DNS in a way. Instead of spanning VLANs between all the buildings, which would be a nightmare, we create this database. And this database has the host address as well as the switch address where that host is coming from. So this switch, if this guy is 10.17.1.10, let's say this guy's 10.17.1.11, he wants to talk, they're both on the same subnet, 2 different locations. He'll go and actually he'll send a packet out to this. The switch will go ask the mapping database or the list server, and the list server will say, oh, he's on can't see it, it's hidden behind this line here. 12.2.2.1 is the loopback address of this guy, and he'll create a VXLAN tunnel between the 2 locations, and then can send traffic between the 2 locations. So essentially, it does a DNS lookup or IP address lookup. So that gives us the ability to separate the location from the identity. This was the provisioning part. I'll briefly go through this. So in order to bring a new switch online here, the switch would do a DHCP request, get an IP address, and then the server admin could, or they need to have the ability to do that on that subnet. The network admin would go and do some pre-provisioning of the configuration into the APIC controller. The installer will go in and install the cables, connect the switch, and then based on the DHCP address, they'll get the DHCP option back, and talk to the APIC controller, grab its configuration, and he's good to go. And then the network admin, this picture shows, he can monitor the status of that. So the whole idea is to auto-provision that, but in order to, like I said earlier, in order to auto-provision, we have to have standardized configs across the entire environment. And that's done by 802.1x, removing the VLAN dependencies, having the ability to have the host mobility and things like that.
Is the APIC EM the same as the fabric control node, list server mapping? They're different?
They're different, yeah. So this guy, fabric control node, is that mapping database is all he is. That's called a list server, and you can look that up. APIC controller is a separate device that
not shown on this diagram.
Not shown on that diagram, yeah. And it's the one that can auto-provision it. It's also going to have the inventory of your entire environment. It also can do path trace. It also can do some QS stuff. It's going to be Cisco's central tool to manage the Cisco network.
And you need Prime to send out the config to the switch, or is that now?
No. Well, yeah, you can, but the APIC EM, we're probably not going to leverage Prime for that piece. We'll just leverage the APIC EM, and then we'll build those templates. And those, if you have standardized templates, then we don't need to have dependencies. So, and then we'll have some automation pieces that go into. So the APIC EM, similar to the APIC and ACI, is all API integration. So we can write custom scripts to help with that.
Thank you.
Yes.
Are you able to audit configurations from APIC EM?
Yes. Well, it does have. It will record. It will grab the existing configuration. There's no auditing tool in itself, but it does have a database of that, and you could use those APIs to go and audit, verify that they have security and stuff.
Okay. What kind of functionality actually requires IWAN? Like which? Because IWAN is the only paid service, right?
In APIC EM, as far as I know, yeah.
Okay. Do you use IWAN?
We don't, mainly because for a lot of our hospital clinics, we have like 1 gig or perhaps even some 10 gig links. So we treat them as more of a LAN environment than a WAN environment, even though they're remote locations. Because we have dedicated circuits, we run MPLS across those links. Yeah. So we don't really use IWAN or any WAN, typical WAN solution. Because we have a typical bandwidth that we would have on a back solution. Yeah.
Tim, what are you connecting your edge switches up to? You said you had 3850s on
So,
the edge, and then what was the devices up above them?
So today, these are all 3650s, 3850s, 4500s, and then our distribution routers are Nexus 7Ks. This one doesn't matter what type of device. This does matter. Okay. These have to be 30s, and they have to be like 3-4 years old or newer. So they can't be 2900 series and they can't be 10 years old. Although we have also, what's not in this picture is we have some DMARC switches here for each one of our buildings. And so you don't necessarily have to have it all the way down to the edge. You can have like your DMARC perhaps be that, and then you can have some HP switches or older switches in the mix as well. So it just depends on what layer you want to bring this down to. It's ideally done closest to the edge as possible. Kind of like that ACI we talked about. It's closest to the edge to apply policies and QoS and all that would be ideal. Yeah. So, any other questions on campus? Patrick? Sorry. Well, thank you.
Thank you, Tim.
Thank you.
Okay, we're at our break time a little bit late. Marla is going to give us some instructions. Dave's going to do our picture with his fancy drone thing. So, Trevor, where are we going for the drone picture? Do we have that figured out?
Well, we can go 2 places. We can go right outside here. However, it is very windy. right now.
Great.
And if we don't want to do that, there's some large stairs right over here next to us, and we can do it inside. We just all stand on the stairs. We have
The drone inside.
2 options.
Sure.
More contained. Or how would
So do we want to do the stairs
I
then?
see the tree moving a lot. Right now, it's in the lull.
See how good it is.
I'm worried about us in the wind or the drone in the wind.
Oh.
Little of both.
about the drone.
Nah.
Anyways, one way or the other, let's be back here at 10:45.
Oh, we're
But
fine.
please,
We're totally fine.
okay, let's go out.
All right, so we're outside, and where are we? So, well, I'll go out for the picture then.
Yeah. One that says anything about putting the labeling on it.
No, this is just that they're going by these specific things. They're not, most of it isn't talking about this.
Sorry to complain.
Oh, it's okay, the traffic is crazy.
Yeah. The guy next to him had a seizure. Really? So the fight is running down the aisle, he just, and they're trying to control the cow.
And this is Southwest, too,
Yeah.
right, where it's like, here's your ticket, get on a bus.
We got medical priority to land. I've never, well, 37%.
Incredible.
I don't know. What are we doing? Said that I was litter. Yeah, I don't. Oh, I have to ask Marla.
Okay.
I'd take a group photo or something.
No problem.
Sure you can. What should I do? Oh, good.
So my son-in-law, who was like a drone fanatic. Yeah. The art stuff. Has it flown it for you? So I have an app on here that you can use like the Google goggles. Phone. Yeah, that's fun.
I want to see that flying women.
I was okay with Windows. I flew yesterday in some pretty stiff wind like this.
All right.
Trying to keep the photo. I'm like, okay, this is a little stiff, but it was a lot stronger now.
Wow.
But then everybody's like, oh, I'm gonna be downwind of this thing.
It's a hammer Gaussar.
Does it automatically correct for all that?
Oh, yeah. Yeah, it's got 2 GPSs, 2 magnetometers, 2 barometers, doesn't differential everything.
Wow.
Yeah, I could easily.
Gosh darn it, we should have done it.
I know.
It would have been different to start if you had manual.
It's on. Hey. Well, maybe you can be. We'll do it on the drone.
Yeah, I didn't know they pushed it up a half hour.
It doesn't help that the traffic slowed everything down as well. What's this? That looks like some kind of Amazon Echo.
Yeah, I
on
know,
steroids.
exactly.
It's a Logitech conference cam.
A Logitech Echo.
Logitech Echo, pretty much, yeah.
So is there an HDMI to this?
Oh, okay. No.
No?
No, you need to put your presentation on a USB stick and stick it in here. Otherwise.
It's a Prezi.
Online?
Yeah, mine will need to run from my Surface too, because I'm running it locally. I'm not.
You could join the Hangout too.
Yeah, if you join the Hangout, or you could log in here to your Prezi. Yeah, go log into your Prezi account. Where's yours?
I downloaded the Prezi locally because I didn't want to be online.
Okay, but yeah.
So it's
it
on
needs-
here.
Yeah.
Why can't it run from there?
If you join the meeting, because this is the
Okay.
machine that's sharing its screen,
I see.
not this one.
I'll test it before I go.
Okay. Yeah, if you join the meeting, then you can share. Well, you have to join the meeting and then present your screen, because that machine's already presented.
Is anyone besides me free?
I'll be your guinea pig.
Yeah, I could run my Prezi.
Oh, we turned it.
I'm doing a
Read that in
Prezi,
there.
but,
Blame
really, I was just doing a downloaded Prezi just to be more safe.
No, I need to get a.
So what are you using for this? Oh, it's
I did, I mean, I had it in,
Prezi?
So he's online.
still loading.
We had the same setup. I had a Surface and I had mine on too.
But I've got that, Prezi doesn't run the videos very well.
Yeah, I know. That's why I had downloaded the videos on there too.
Yeah.
We'll see how they work. I had a couple of videos there too.
I haven't even seen this, so, I'm not even gonna take any credit for it. Maybe.
I get the credit hard boy, like, if it takes.
He should have read it. Or if it's fabulous, like, look how great he is.
Yeah, it was me.
Isn't that weird? We got some sort of camera going somewhere that's.
So,
Some videos too?
time, well,
I can take that one single away. talking on 3 other radios.
That shows 6 lives and 6.
Or how they got a profile for us, so that the power way down. They're 2 forms, it's just like 1 milliwatt.
Hey, John?
John? You're the same one with that. Sure, you support me.
I was having some sort of problem with my mail. Logging in. Did you log in? I want to say that.
I have it on my, I have it.
Yeah.
So.
I know where it's. Yeah. Oh, that's right.
You want to try yours again?
No, it's just good.
I did that right. No. So, there, now we're going to the you sure it's in my mail?
The other thing is they got the back down. Instead of the size. The 1810 is actually a little bigger than
Yeah, man, how's it going?
Well, once you get those spots, which generally still have to see about
Most of that. Got a plan.
So those guys are.
Yeah, and it gives.
Log me out?
And like Jeff back down for the last minute.
Maybe not yet.
Did you get in?
All I was just logging in as me on my email now. So okay, you killed it. That's good.
I didn't shiver, but.
Okay.
This, no, that won't.
Mine.
Yeah, I was thinking about it too. Hey, what'd you do?
Sit it down there, and you can use laser too.
Wow.
We try.
We need a presentation.
Is your video audio coming out there though? Have you tested that? Oh, okay.
Video.
You remember?
All right.
So we could fly right here. I'd fly right here.
We'll do it. For your class. Weather is cooperating.
Today, it was supposed to be today.
64 for a high day?
But you're gonna do All right, everybody. Get back together. We can just start words, let's get back. We're a little bit behind, so if we want to go ahead and start. All right. Thank you all for being accommodating. The wind and the weather kind of messed up the photo outside, but thanks to Jim, we were able to hold the really expensive camera and everybody. What?
Steadicam.
Yes, it was a Steadicam. We're going to now turn the time over to Neil. He's going to update us on the ServiceNow initiatives at BYU. As you all know, Brad used to update us on that a number of years ago, and BYU's got, I mean, how long have you been using ServiceNow? 5 years? 7 years?
7 or 8.
So anyway, go for it, Neil.
Okay, thank you. So I work with John, Sonderland, and the topic that I was given was expanding value of ServiceNow. So I'm not sure exactly what your interest was, so I Thought I'd just show you what we've been working on over time the last couple of years. It's gotten really exciting, the synergy of what we've been able to do. Believe me, it's a work in progress, so don't assume that we've got everything running as a smooth oiled machine. It's definitely still a work in progress. So when we talk about ServiceNow, ServiceNow is our IT service management tool. So when we talk about expanding the value of ServiceNow, it's expanding the value of ITSM, IT Service Management. And the goal, in my opinion, there's all sorts of complex definitions of ITSM, and all of the complex discussions around it. But really, the bottom line for me of what ITSM is just designing and delivering robust and resilient services that are useful to our customers. And to me, robustness is about increasing the mean time between failure, and resilience is about reducing the mean time to restoration. And I think you can all think of certain systems that can be quite robust, but when they break, they take quite a while to restore. So the sweet combination is something that doesn't fail very often, but when it fails, it can be restored quickly. So how do we expand value? Two ideas that I'd like to share with you today on how we've done that. Sorry, I'm pressing the wrong one. So one is the CMDB itself. That's a key part of our use of ServiceNow. And that's a complete contextual awareness of the whole IT ecosystem. And the other one that we'll talk about in a moment is the integration of the CMDB with our system event analytics. Kelly McDonald, when he was at BYU with us, Scott, John, and I started on the idea of data streams, syslogs, and all sorts of other machine data and information that tend to get put into a file and logged away until something fails, and you get through that bucket and you find out why it failed. If we can look at those system events in real time, coupled with other things, all of a sudden we can change the outlook on how we address things closer to real time rather than after the fact. And then get that coupled with workflow automation and take care of things that way. So let's first cover the CMDB. Complete contextual awareness of the IT ecosystem. For us, there's 8 primary areas of what that covers. The servers and storage, whether it's at our data center facility, we're all dealing with hybrid environments. So whether it's in our data center facility where we dive deeper because we have to manage deeper, or whether it's in AWS or other cloud services where the tree of dependency is less deep because there's more managed that's outside of our domain of management. So we don't have to map as deep. The network, software and databases. In our case, in our office of IT, we also manage classroom technology services. So things like everything that's in this room to provide this environment. People and groups, security and access management, the financial and asset aspects, and the facilities and GPS aspects. So you've got master data repositories. Our goal is to have event-driven updates from the master data repositories, mapping or populating the CMDB so that then there's a whole synergy of things that can happen when you have all of these relationships happening from these different repositories of information that each contribute a little piece of the whole context of what your IT ecosystem is about, so that you can manage the whole service, not just individual siloed components of it, not knowing what other aspects of it are about. So let's go through just a couple of examples quickly of some of that, what that represents for us at least. So for example, I know WestNet's a lot about networks, and I didn't worry about that. We've got literally hundreds of network closets around campus. So one of the things our network installation team has is detailed information about each of our network closets. Plus, in our CMDB, we have photographic information of those closets. And any one of these images can be looked at in a magnified fashion, so that as our network installation management team sends a technician out to do some work, they can actually pull up images from around campus and give them detailed instructions on a particular work order so that they're familiar with what they're going to see before they get there. So they don't have to send them out and not understanding the details of the work order, coming back, then going back out because they didn't understand it the first time around. Plus, we have information on incidents related to those areas, change orders, knowledge bases, maintenance, tickets, inspections, all sorts of information. So again, it's not that you don't have all these things individually. CMDB gives you that connectedness so that you go one place and whatever you need to go to, whatever piece of information you need, it's interrelated and all available to you depending on what you need. Even to the case of like if we were looking at a network device, you have an original work order that was ordered on, which can then take you over to your purchasing system, give you the whole history of the ordering history of where that device came from. If you need to know that because you've got a device that busted before its warranty was up, so you can RMA that and associate the return device with the device coming in to replace it. We also have a representation of our data center in the ServiceNow and CMDB, so that we know our hot aisle cold aisle configurations. We can click on any row that we would like and see a representation of that row and have all the CIs, whether they're network or storage or server related. Click on that, get to the detailed configuration item record, go to whatever related items, go to whatever tickets, RFCs, do analysis on any of that because it's all related and available. I just recently helped the financial management team. They're trying to change and optimize and be more efficient with some of their billing approaches. So for example, just because we again have this interrelated set of information from all these disparate master data repositories, we can now give finance, for an example, a way to provide billing of these thousands of IP telephones spread across campus. Because now, just from a report of the CMDB, we can tell them this IP phone is connected to this jack, and we know where the jack is, in which room, in which building, also tangentially, which person is also in that room, what group is that person related to, and thus what invoice that phone should be attached to so that the appropriate department can pay the appropriate device that they're responsible for. Likewise, another one related that we just were working on is we are considering a billing model for network equipment by access ports by building. Again, because we've got this related information, we're able to provide a detailed report in ServiceNow, which lets us exempt certain access ports that are in the data center certain access ports that are in construction trucks, construction trailers, certain access ports that are related to radios, the ones that aren't appropriate to build by, because they're exceptions. Then generate a report that we can then pass over to Excel. I've got an enhanced request to our tools team, and we can also do this in Service now that we can't do just yet. But then you get a total access port by campus, by building, or deep analysis into this building has these particular network devices and these edge ports. So you can do your planning. You can also do a further analysis of knowing which ports are populated, which aren't. And I'll get to another, well, let's talk about it now since we're talking about it. You also have your network information of what VRFs are with what routers, what VLANs are on what switches, what VLANs are on what ports. So all of a sudden, you have a report immediately on what PCIs are exposed on what jacks, which are tied to which ports, which have which VLANs exposed. For example, any other permutation like that that you would like. Should have that discussion right here. So the SSIDs, your ports, your jacks, your VLANs, your VRFs, your routers, your switches, your endpoints that you want to put in scope of your CMDB. So in our case, and in many university cases, desktops and laptops are not in scope of BYU, but servers and time clocks and phones and security cameras and such are. So some of these endpoints are in scope, some of them are not. In corporations, a lot of times the laptops and everything else are in scope, so you have another CI type that is quite populous. So whatever your situation, what goes into the CMDB is whatever you have to manage from a business standpoint to provide the services you provide to your customer. Like I said, with our classrooms, here's a classroom in our math building. Here are all the devices that comprise that AV tech room system. And we can even become the master data repository where there exists none. So for example, here's some settings for one of our restaurant control units because it had previously just been kept on an engineer's desk in a spreadsheet because he had no other place to keep it. So in some cases, when you need to, your CMDB can also be the master data repository when there isn't a sufficient tool outside that is providing that capability. So this piece of information about this device for this system is mastered in CMDB. That's not usually the case, but it can be the case. And then, like I've said before, for this particular tech room, like this classroom, you can know the history of all the incidents, the history of all the RFCs, the inspection history, the maintenance history, any KBs particular to unique aspects or details, everything available about this system in one location. Likewise with security cameras, we provide the video surveillance system for the police department at BYU. So organized by building across the campus, and of course there's some autonomous ones that are maybe on poles in the parking lot. So it's either associated with the building information system or a geographic information system when there's no building to tie it to. So again, in this case, we have the camera with the detailed information. And the nice thing about your CMDB, apart from your management system that is the master repository, the CMDB gives you a whole audit transaction history because it knows the history of what's been going on. And that's been useful for our engineers, actually. And then for a software dependency map, where you provide in like a web app, for example, you can know all the relationships there, where it runs on, what database it's dependent on, what load balance servers it's running on, how it's authenticated, what the access management is, etc.
You have to confess, that's about the hardest one to keep accurate, right?
Right now it is.
Which one?
Software.
Software. Because there's so many different developers and so many different ways, from waterfall types of PeopleSoft types of apps to land as an AWS. It's tough.
I got a quick question on that note then. Is keeping it up to date automated, or is it all?
We have a repo meta file aspect for those developers that are like doing things to GitHub and such. So the part of the requirement for development, as they commit it to GitHub, then they post an event that then gets subscribed to by a microservice that then populates the details of the CI plus its relationships. That's where we're going.
That's where we're going, right?
But that's not where we are.
Yeah.
But we've got commitment from software developers, because that's actually a great advantage to them, because we're dealing with so many granular parts now that with that discipline on their side, it's valuable to everyone.
Yeah, if we were 100% in AWS, then we're probably about 1.5%. Then you'd have everything captured that way.
Right. Okay, so that's the CMDB examples. Let's go to this other one of now integrating the CMDB with system events with workflow automation, and then things just explode. So integration of CMDB with system event analytics with workflow automation. So now you get a data analytics information architecture where you get contextual awareness, you get predictive analytics. So instead of all these syslogs going into a bit bucket, you move from being a medical examiner, finding out why a patient died after the fact, to becoming a medical doctor, diagnosing and healing a sick patient. And what does that do? That increases the mean time between failure, because you repaired it before it failed. And you reduce the MTTR, because when it fails, like on that software example, if you get the alert on you always get the alert on the elemental element, like the server that the software is running on. If you already know the dependency, then the service desk is not running around wondering who's affected when this element has a problem. You already know. The root cause analysis is already done when you have the dependency map in place. So this is something that's just provided amazing return for us. We're just at the beginning of it. And let me quickly describe this for you. So our system event analytics stack is this whole thing here. It consists of feeding whatever kind of logging information, whether it's wire data, machine data, agent data, application logs, or even synthetic data to simulate user information. Going into the Elastic stack, I'll talk about these in just a moment, and then being visualized by either Kibana or Graph or Report. We're creating an interface from Elastic to Tableau as well. So that's the C stack. What we also do is have a workflow automation stack that can then import reference data sources, because usually when you think about the Elastic stack, you're only thinking about one type of database or index, and that is the time sequence data, which is very, very useful. But when we couple that with all that relational information about people and buildings and GPS and tickets and CSRs, who's responsible for subnets, when you get a compromise, you get some attack coming in or some rogue server inside your network, and you're saying who's responsible for that, all of a sudden all of your CMDB information can be coupled and indexed as static federated reference data sources. You do processing, workflow automation processing, so all of a sudden you couple that together, and then sometimes you just act on it, other times you create heuristic synthesized data, which is that combination of the real-time data coming in with your static CMDB reference information that you have, because you have a whole contextual awareness of your ecosystem. Then you create tables of information that also become useful, because then sometimes you can get inferential information like, well, this laptop isn't mine, but I've logged in, there's logs that I've logged into it enough times that we can create an inferential table that I bet this is Neil Harrington's laptop. Not because it's registered to me or anything else, but because log information tells me that's probably Neil Harrington's. So you can create additional information based on intelligence. Then this gets to a place where, so this is where we can get predictive analytics, automated actions can come from knowing that certain logs need to generate certain tickets to the ticketing system or certain actions, like you detect some intrusion, you disable somebody's laptop, and then you have assisted responses through a combination of a Hubot in the Slack system. So you have a robot that once the threat has been addressed on somebody's laptop, so I get attacked and compromised, so my laptop is cut off from the network. So I'm contacted by the service desk, they tell me what I have to do. I do it, I clean up my system. Now, the service desk can execute a command in Slack that then runs a script, so the service desk isn't making any mistakes in re-enabling me. It's just assisting in the execution of scripts and commands that then reduce the mistakes. So again, our mean time between failures go up, our mean time to restoration goes down.
So do you have any specific examples of like what Nick's using this for, or?
I'm glad you asked.
Okay. Thanks, straight now.
Okay. So, John had a computer science capstone project that we used the GPS data of each building location with our log data of each access point. And here's a week in time history of access point activity through the week that then gives us insight into where activities are. We want to improve this so we can do it on a floor-by-floor basis. And just dreaming, think of providing a mobile app that gives you the current heat map of the building, and students are frustrated because they're having access problems at one end of the building, but they just look at the map and you're not telling them where to go, you're encouraging them where to go because they say, oh, if I walk 100 feet over here, I got all sorts of access. So some really good.
So on that video, so it looks like each location just has one dot, so all the access points are being kind of aggregated.
Yeah, we did
Right,
that.
because we, in our stage of progress, we didn't have a GPS location for each room or a GPS location. We want to get to a GPS location of every access point. We just weren't there yet.
So you just, that makes sense.
Yeah, I just gave them a week. I gave these CS students a week's worth of log data, and then they could know easily what building it was in. They did do another one where they did it kind of on floor in a particular building, but it was a little harder for them to parse that all apart. So this was sufficient for them to get an A in their class or whatever. So.
Again, I just wanted to give you that as an example of the kind of where you can go with this, because you're mixing log information with CMDB information. So Virus Tracker is one of our security teams' Kibana dashboards that's coupled information, again, from logging information and from CMDB information. So as they detect certain vulnerabilities, they can pull in the CSR database so that we know what subnets are on campus, what support groups are associated with what subnets, what CSRs and secondary support CSRs are associated with those subnets. So whether it's a compromised server on campus or some compromised user, there's a quick way to get the contact to the right person at the right time quickly. Again, in this case, reducing mean time to restoration.
Hey Neil, are you back-ending all of this in Elastic? Are you back-ending all of this in the Elastic Stack? Like this data?
Oh yeah.
Okay.
Yeah, and in fact, we find that even if it's readily accessible, because we could easily do this two ways. I mean, you've got this workflow automation, so you could do your queries this way and this way all the time and do something. But at least what our initial developers have found is do this once and create an Elasticsearch index of that information. They're not very big because they're not time series stuff. So they're really small indexes. But once you put them there, and just do it on a regular basis, so it's fresh, then all of this work is always happening out of the Elastic Stack. But you could do it either way.
So Neil, how does this integrate then with the ServiceNow CMDB or what you were describing earlier? Where's the touch point there to?
Right here, where whatever process you want to run can integrate any information, because ServiceNow has a RESTful API. So whatever CI of interest you have, whatever element of information in the CI you're interested in, you can make that query and get that information. Or
So let me give a specific example of that, because I don't know, I like looking at the pine needles instead of the forest sometimes. But the police want to be able to find where somebody is on campus. Over in the CMDB, we have tables that tell us who owns, actually it's ServiceNow, it may not be in the CMDB. ServiceNow tells us, who owns which MAC addresses. That's probably not where it's going to be in the long run, but that's where it is today. So, I can know, Mike, all of your devices, all the MAC addresses. And then the Elastic Data's got information about where we've seen those devices associated, right? So you pull data from two places, and we can find people on campus if the police need to find that, right? So
right now, we just give a list of, like, let's say the last 48 hours, this person's MAC address has been in these locations.
and we've reduced it to the simplest running in Slack. So we have like a QBot running there, so you can type in a MAC address, you can type in a person's name, and only the police have access to this, and it'll show them everywhere they've shown up in the last 48 hours.
Then the next step of evolution is to put that on a map like I just showed you, and give a color-coded history so that they can actually just see the trail of where they've been. Because again, this is a public safety issue in particular. This doesn't go out to everybody. This is like 3 people in the police department, so that there is an ability to track dangerous people.
But it's pulling that data out of ServiceNow or out of CMDB and combining it. It reminds me back when we started on web services, and you create web services, you never knew how they were going to mash together to do cool things. That's exactly what we're finding, kind of another version of with Elastic and all the other data sources that we tap into. And you can do some really interesting stuff. I don't know if you're going to show up, but like Nick quarantines, he's got a QBot now that quarantines people, right? And they can
right. That was the example I just talked about. And also back to Elliot's question and back to your discussion right here, we could do that query on the fly from here and from the data here. But previous, we do the query of what net IDs have what MAC devices and create an Elastic index. So it's much faster, and we already have that information available in one location. So then the workflow automation just gets that information from here, gets the log information from here, and quickly provides that information through this assisted response system here, because then your police type in a command, track net ID, and it gives them all the detailed information about the person, what their MAC addresses are, and where they've been the last 48 hours. Huge synergy, huge. So they also happen to be using Kibana as a ticketing system. If it needs to also, our service now is our ticketing system. Security has created their own custom thing where it's just they have to be aware of it and such. If any security incident needs to get pushed over to the official tracking system, again, a command can be executed here with a button push to translate everything, all the information in here to a ServiceNow ticket. So again, automation. Likewise, web threat hunting. I won't go into details here, but again, it's just a combination of information. Palo Alto logs coming in, CMDB information coupled with information from the Palo Alto logs and other logs. Remote desktop protocol attacks. We used the graph feature and an XPacket add-on to the Elasticsearch. All of a sudden, we find a particular host from outside of BYU with all these different users logging into all sorts of these places, and one particular user logging into all these varieties of systems at BYU. You all of a sudden find kill wherever you need to using graph as a hunting tool. So sometimes you're hunting because you don't have the automation in place because you don't know what you want to do. So hunting is where you guys are just subject matter experts and using these tools to just swim intelligently through the data. And with tools like this, you get rid of all the garbage and focus on the really crucial information.
So in this one, clearly it's using log data. What else was it?
So in this case, this one's just using the
log data.
Yeah, thank you for clarifying that. And then per John's conversation, here's our here's two of our robots. One is the nice butler called Jarvis, where you say, give me a report on this guy, and then transition into the police guy, where he's providing confidential data, and this provides the private information. And then I was not able to get the time for this presentation, the example of not only was this, but here's the MAC addresses, and here's the last 48 hours of where those MAC addresses are showing up.
Just checking, are you getting, oh, well, there you go.
I checked, this is a time check.
I was just checking if you were getting close. I said, well, there you go.
Close.
Conclusion.
So, ServiceNow coupled with system event analytics, coupled with workflow automation. This is amazing. And just to go back to this one diagram, the other really valuable thing is the fact that Rundeck takes care of a ton of the housekeeping. So instead of your network engineers and your security guys doing all sorts of web app development and everything, this kind of system takes care of all the housekeeping around those kinds of things. And you're just dealing with particular scripts that you need to deal with. And this provides a whole audit trail of everything that gets executed by this workflow automation. So it gives you a whole history of, okay, that automation did something, I'm not sure what it did. You get the whole audit trail, and it did this, and this, and this, and this. And likewise, in your ServiceNow.
Well, before you do that, so the Rundeck stuff, let me put a comment that Nick Turley shared with us. He had a lot, he joined BYU recently in our security team's security architect. And the security team had lots of little applications, web applications, and different things. They were having trouble maintaining and creating, and basically got rid of all custom coding and was able to replace it with workflow automation. So using Elastic as kind of his core security SIM, and Rundeck, and he's been able to replace all those customized security apps that our team has built with just a much more standard way of doing it all. And that's been a big win for our security team.
The good news and bad news of us making extensive use of student employees is that we use student employees. Because they create a cool app, and they're here for a year or two, and then they go, and then we got this, nobody understands. This architecture kind of gives us the best of both worlds. We can still use student employees extensively, but now it's organized, piecemeal, less prone to spaghetti. You can still do spaghetti because you still have that and this and all that other stuff. But we've at least got step-by-step audited history of what those automated workflows are doing. So I guess my conclusion is a data analytics information architecture incorporating CMDB, real-time system events, and workflow automation, giving you predictive analytics, automated actions, and assisted responses. And I can't emphasize that enough. Instead of operators, whether they're network engineers, whether they're operations center people, having to type in script information to re-enable somebody or change a configuration of a device, making a fat finger mistake or a brain freeze mistake. If they just have a command to execute instead of a script to execute, things are better. And then you have the audit trail through the automation, so if some mistake happens, you know exactly when the mistake happened. You fix that workflow, and it's fixed forever, not just the one instance.
So I have a quick question.
Sure.
Maybe
I'm
Elliot.
deaf in my left ear, so.
Okay, maybe Elliot can help me out on this one. But part of what seems to be under the hood here is that you are parsing all of these different log sources correctly. How did you get to the point of doing that? I mean,
So we have
that's
a-
an enormous amount of work.
And how many people are doing that?
Right.
So we have a discipline process where a person on our platform team is responsible for this stack and making it operate well. And again, we're maturing in this, so I'm not saying this has worked perfectly, but our approach is that somebody wants a log to come in here, part of the requirements before they submit it, the person here is responsible for parsing. He's not responsible for interpreting what should be parsed. The data steward of the log, like say one of our network engineers wants the Palo Alto log to come in and be parsed. It's the network engineer's responsibility to say, here's an example of a Palo Alto log. This piece is the timestamp, this piece is the IP address, this piece is this piece is that. And then also, as those values are coming in, match it against what other field names we already have, make sure where we can match up field names. We normalize on the data types, so that like IP address never comes in and we just give it a text field type. We give it an IP address type, or IP4 or 6.
Right.
And so we normalize and be consistent. But if a data steward wants to feed this, he's got to provide how long should the data retention period be, what are the parsing rules, et cetera, et cetera. When he's provided that information, then it comes across to our parsing expert and our Elastic expert that can then, when he's got that information, he's actually pretty quick.
And does your expert provide guidance to the data stewards? For example, I could have a bunch of network engineers that might say, well, the retention is forever.
Right. Yeah, and then like I'll manage the steering committee for the Elastic.
Yeah, we got to the point, that's the important part. We got to the point where we had to have a steering committee, right?
Right.
We had enough people who were interested parties in this, and we get people from different departments together who all have an interest in this, and we
Great, okay.
And so then we mitigate, well, that would be nice if you'd either like to pay for another petabyte of data,
right.
We'll do it, or this is how much space we've got, so we're gonna give you this much.
Yeah, or conversely, they could say, well, or I could, you don't need it at all, maybe a day. And that could be
Yeah.
actually a hindrance to the organization.
But that's where you work across the aisle and realize what's best for.
None of this was meant to slow things down or hinder it, because it really hasn't. It was meant to facilitate it and to make sure that if somebody's gonna be sending a bunch of new logs, that, our platform team knows how much is gonna be coming, so they can do, and they're proactive. They came and said, what new logs do you think you'll put in this coming year that are of any size at all? And then they submitted a request for additional storage based upon that input. So it's a proactive process.
Palo Alto is bigger than everything else we got put together. Our AV logs that we're gonna be uploading here shortly, they're like, however long you want, there's not that much coming in.
Well, what's funny about our AZ logs is they first decided to send them out to us, a cloud, right, version of Elastic, and they were paying $1,000 a month for their AWS instance. So
for an old version of Elastic.
For an old version of Elastic, we don't even care. I mean, that's the little data. We don't have to order any more storage for that one within our system.
Okay, thank you very much.
Thank you.
All right, I need a small vote. We're over.
The other parts
Lunch is being set up.
Want to eat lunch while I talk? That would be fine. Who'd like to eat lunch while I talk?
Well, yeah, so one proposal is we go ahead and get our lunches, and then Jim will just talk over lunch. Does that work?
Is it snowing out yet?
No, it's raining, and it was a nice walk down here.
And as you might expect, we're rethinking our drone flying for tonight. Dave is set up. The weather is forecast to be dire. So there was a question, how many people are going to still be here tomorrow night and are staying for the OIN workshop? Not everyone, but, or could stay. We got to go to the OIN workshop. So it looks like maybe half will still be here. So if we can't do it tonight, we'll reschedule for tomorrow night. Anyways, we'll see how things go, but it's not expected to get better if you believe the weather forecast. So it's not supposed to be real great tomorrow morning either. So as you know, I married somebody who pays a lot of attention to the weather. So the weather's an ongoing event. All right, so I think she's almost done. It's box lunches. Go ahead and grab your lunch and come back in here and take a quick break, maybe.
That's it?
It's it.
It's easy, so we'll grab our lunch. It's just that link I need to bring up.
No, I was figuring it'd be like one more per slide.
I could have made it into about 500 slides of course.
So do we have to use this PC to do our presentations, or is there a plug?
You can join.
So if I've got an Apple Keynote, an Apple connection, I've got an HDMI. Oh, well, it's Keynote. I can port it to PowerPoint. So, but this is on the Hangouts, right? This system is this so it's best to try to get it on
You can
there.
try to run Hangout, like it is HDMI.
Well, that's an HDMI server right there. So you can just plug in HDMI. Maybe sometime later today. I don't have anything till tomorrow, but I just want to be up against. I can always port it out to PowerPoint or to PDF. Cool. How are you? Great. How was the trip out? Yeah, these guys are saying it's been kind of hot out your guys' way.
Oh, it's like 94.
In Boulder? Oh, wow. So Denver was even hotter than that. Wow, that's hot for Boulder.
Well, I said. Yeah, so.
I'm trying to.
How come you don't have prompt enabled? Google prompt instead of the codes.
I have a YubiKey and I usually use it. That's my key.
Because there's an option called Google Prompt.
So is it like?
And it just pops up. Yeah, it just pops up on your phone. Yes, no. Yeah, it's under apps and there's a little code box.
Yeah. That would be interesting.
Oh, did you just log into Chrome? What's adding all your plugins? Yep. I might have just merged accounts. What's that? You should be able to see it. Yeah, if you go down there and go to the get started Here, I'll finish this. You'll see it. You'll see the key on 7 screens.
We should do a full I have to come down. Which is hard to get around here.
But the other thing is
my computers, I shouldn't need the key.
It's like, oh, well, does it work? Just page down. Finisher. That's
All right, everybody got lunch?
I love green lights. So you got
Oh, yeah.
Sweet.
Just take some seats here.
That's up. That's it. And then leave it. Unless you want to use the wheel.
Sweet.
We need the wheel for micro.
Oh, okay.
Micromanagement.
So for micro adjustments?
Yes.
Okay, should be lots of fun. Are we ready to go?
Whenever you're ready.
So Dave was a little disappointed that I didn't have my presentation with 500 slides, but I didn't have time to do that. And thank you, Marla, and whoever else was gracious enough to move my presentation. I really appreciate that. It's good to see all of you here. It's good to be here at home, but I think you probably mostly know what the problems are being in your hometown when you have power outages, especially since it's walkable. But I hope you enjoy. I've been watching the weather for a couple weeks, and it looks like the 2 days at WestNet are the 2 worst weather days we've had in a long time. The way it happens at WestNet. So I wanted to talk today about risk assessment, and what happens is, if you're like me, what happens to me is that about every couple of years, something happens and I start to think about risk assessment again. And so, so it's a hard thing to get my head wrapped around it. A couple of years ago, we were doing some assessments, and I was standing in a middle school in Washington County, down St. George, new middle school down there. We just come out of a session with the principal and his administrative assistant and the head of the district for food services and some other things. And we've been asking the question about, one of our questions that we ask every time is, what technology or technology services do you use to do your job? And whatever else comes back, one of the things that comes back for us is the network. And at the same time, we had just made major cuts to our NOC budget where we really managed the network out of. And I started to think to myself, knowing and seeing what these stakeholders were doing to depend on our network and all of the things that they got layered onto our network. And we were, as a management team, making decisions that would actually take resources away from the network and managing the network. I started to wonder if I might have some actual personal liability if something would happen, knowing that I had made those decisions or been part of that management team, leadership team that would be making those decisions. And so I started calling around and looking for a good risk management methodology, just something that could give me a quantitative way of showing to my boss some sort of risk assessment, some risk factors. And there actually were a couple people on campus at the time, they moved on, but they had some risk methodologies, and they shared those with me. And I was really quite fascinated with the complexity of those risk assessments, because they start to give you things like, you're going to assess, is it a hurricane zone, is it a tornado zone, is there flooding, is there, all these different factors, along with, and most of them are data centric, so a lot of discussion about data, a lot of assessment about the data that you had and how you deal with it. And so I looked at that and I thought, it's just way too complex. There's no way that I'll ever get through this, let alone try and take a team through this and even have any understanding when I got done really what the risk assessment was. And so because of that, and just struggling, and I thought, I don't have enough time to become an expert in risk assessment and risk management. So, and I couldn't find anything else. And if somebody has a better way of, and I've shared this actually out with several different groups, this is my personal IP. I developed this methodology for myself. I've actually taken this, we have 72 services at UEN, 73, something like that, maybe up, maybe down from a couple of years ago. I've gone back and looked at the list recently. But what I thought is that I would develop something, and I really envisioned that I would be able to go in and for each, maybe not even organization, but department maybe, and just list all 72 of those services on separate sheets, replicate those out, and then go through this methodology for each service. And so I've done that personally, and don't ask me to share it because I know. At least I have done that for myself. Now, I don't know how effective that is, because I don't know how objective or subjective I am about assessing services that are provided by other departments. And when I first started looking at this, I thought this would be something that we would assess internally. But then I realized after doing this for a bit that you could also give this to your stakeholders and let them do an assessment. And so it's lightweight, it's pretty easy to deal with, and there are 7 risk factors that I've boiled this down to. Now you can add risk factors to this, and what I'd say is that if you are interested in this, if you want to deal with this at all, you're welcome to it. I'm not trying to keep that up. I'll send you the link and you can go out and download it and use it, and add to it and change it, do whatever you want to. But for me, this was the simplest, quickest way to quantify risk within my organization, within the areas that I deal with. Now, what I did is, oh shit, the wrong button. Dave, what do I do now? Okay, I'm back. So what I looked at is as a 1 to 10 scoring methodology. You could do 1, 2, 3. You could do 1 to 5. You could do 1 to 10. You could do it anyway. It doesn't really matter. What happens is a 1 to 10. If you come up with something that was all 1, and 1 is the lowest risk, 10 is the highest risk. So if you're all 1s in one service and all 10s in another, you start to see this huge divide, this huge gap. And I like that because you start to drive these large gaps and then start to put in buckets what services were really high risk versus what services weren't. And so 1, 2, 3, you could do that. The other thing that you could do, and I thought about doing, is you could take some measure of dependency and just line these up, and if services were dependent on, other services were stacked on top of one service, and I think about the network all the time, but whatever's dependent on the network, add 10% of whatever their risk factor was into that, or if something's at the top of the stack, take 10% of that and add to maybe those areas that it was dependent on down through the stack. So does that make sense? And if you have any questions, you want to jump in. But I look at it very simply. The first one is mission criticality. So is this something that is mission critical? And the way I want to look at this too is, and they're extreme, so they'll sound extreme, but if you have the criteria, does this service support something that's mission critical or mission critical activities? One is indirectly, it's not mission critical at all, and loss means nothing to 10. Loss means everything. It's extremely critical. And then, you can do this where you say 1 or 10. But the trick for me, and what's difficult, I think, in all of this is how do you determine that spectrum between 1 and 10 within each one of these. And so, again, I'm trying to make sure it's quantifiable. I'm not in any way purporting that it's a science. There's still going to be some gut feel for where that service comes in, but at least you would have some measure of mission critical nature. The next risk factor was reliability. So is it prone to failure? And if there's never or rarely a 1, if it's prone, and then I put at least once a year, but you could actually change that to whatever they.
Wouldn't it make more sense to have less than 10? Because you get really vague, and 3, 4, 5.
It probably does.
I was thinking like 1, 2, 3, like 1, I'm absolutely gonna die. 2, I worry about it. 3, I really don't care.
And that's probably a better way is if you want, when it becomes subjective, that's a great way to do it. So you could change that methodology any way you want to. I did 1 through 10 because I could say if it's on the lower end, I'm going to give it a 2 or a 3. If it's on the upper end, I'm going to give it a 7 or an 8. And so I could start to have a larger gap between those that were really risky and those that weren't. And I was just trying to identify where are the biggest risk services. And so that's what I've done for myself. But you can change the scoring methodology. And I like what you're saying, and I've wrestled that through in my head a lot, because at that point you're just saying, like you said, 1, 3, or somewhere in the middle. Yeah. I don't dislike that, no.
Well, I'm just thinking when someone else looks at it, you know, I talked to Mike, I might say it's a 6, Mike says it's a 7. Who's right? Mike is right, he's my boss. But.
Well, Mike's always right.
Right. So.
I understand. And so, I went the most extreme in this 1 to 10. I mean, you could, I guess, go to 1 to 100. If you had some way of actually objectively measuring it. And I realize that the weakness of a 1 to 10 is how do you objectively measure the difference between a 6 and a 7? The only objective way is Mike says 7, we go with it. Right? Or maybe that's subjective. Anyway, so factor 2 is reliability. Factor 3. And I call this accessibility, but is downtime tolerable? You know, just looking at that. And so if downtime doesn't have any impact, which is an extreme one way, that's fine. If it just takes out all your business, that's the other extreme. So looking at that, and believe me, I've gone through these and looked at, there's lots of different, it could be, you know, some services could be professional development. Does it take a lot of training versus is it intuitive? So you can add some things to this. I'm in no way saying this is a comprehensive, but it's a good way to at least get a baseline and an understanding of different services and how they rank within these areas. 4 would be is there an alternative service? If it's a search feature and there's other search features, then you don't have to put, you don't have to do anything but type in a different search domain, right? Versus if it's a 100 gig circuit, how are you going to replace a 100 gig circuit? There's nothing you can bring up that quickly. So just looking at it from that perspective, security threat, and I talked these through with Troy quite a bit, but are there vulnerabilities? Is it inherent within it? If not, then it's a 1. If there's high potential, then and it would hurt the organization with those vulnerabilities, then it's the highest score. And then security target, is it an attractive nuisance? Is it something that somebody's going to want? So you see the difference between their vulnerabilities and if it's something that folks are going to really be out there searching for. And then, of course, the last one in this is budget. Is it budget or not? And so then you put all of those together, drop your conclusion, you can come up with a score for each one of the services, and then if you did something where you developed a dependency matrix, you could then add 10% or 5% or some amount in just to, because all I really wanted to do is be able to show these services that we provide are more risky for us than these other services. And I just want to be able to go to our board, to my boss, to our staff, and say, look at the difference here between the services that are less risky and those that are greater risk to us. And I didn't find anything else out there that gave me exactly this kind of look about risk. And so that's what I developed. You're welcome to use it. Do you have any questions or anything else I can?
So Jim, when you go to your board and you present that, have they made certain kinds of decisions as a result of seeing it?
Yeah, I haven't gone that far. What I've done is I've actually taken the 22, 23 services that I think are the ones that I wanted to do the comparison. I've done that for myself. And then I use that when I go and talk to different people. If I'm talking to legislators, if I'm talking to others, I have it in mind where I believe the risks are, where the dependencies are, where the other things. So for me, so far, I've just used this to inform myself and some of my staff as I move this along. So I think it's been a great exercise for me to go through and do this. I can't tell you that if Ray sat down and evaluated the services that he evaluated with the same numbers. But at least it gives me some idea and it gives me a basis to have conversations as I'm looking for additional budget dollars and try to justify what we're doing.
Hey, Jim, I think it was 1, 2, 3 WestNets ago, you talked about how you partnered with the quilt.net to do a risk assessment.
Well, we actually did a technology assessment.
It wasn't risk.
It wasn't risk. Okay. So this is a small part of, and it's just one of those things where I don't see us effectively dealing with risk or understanding what the risk factor is. Sorry.
The security item, as vulnerability exists, seems to be a lot higher flux than what the rest of these. Are you sort of keeping that in mind as an average when you're making this, or right now at this moment there's this peak of all these unpatched vulnerabilities? How are you thinking about that?
Well, I'm not looking at it as is it more inherently. So I'm not thinking about it as what today are the vulnerabilities that are out there that I need to be worried about. I'm looking at it as more as, is this one of those things that it keeps having all-day vulnerabilities that keep getting released on this, or is this something that's basically fairly stable? And so you're gonna have to get a lot more sophisticated about this than I have become if you want to get down into that. And I don't purport this to be, if we want to talk about actually a security methodology, you're going to have to go to a San Diego or something like that. Any other questions? All right, thank you. Thanks, Jim.
F11.
What's that?
F11.
If I just close this window, or do I have to log out?
Just close.
You're done, Jim?
I'm done.
Wow.
I do you know.
Way to get us back on the agenda. So now you can just sit and relax and chit chat and socialize until 12:15. Couple things. My admin's just checking on how breakfast was as far as beverages. So, we usually do soda, coffee. Was the soda? I would take soda. So, well, was there enough?
I got one.
It was mixed. The mix appropriate. Those of you drinking, don't know me, I'm preaching, I'll just say it right off the bat. So for those of you drinking these water bottles, I had specifically requested we not have water bottles, that we have pitchers of water.
They had pictures this morning.
Yeah, you got
Pictures of water.
We wanted to continue that topic. But if you're really reading your environmental news and you're looking at the tragedy of plastic in the ocean, and Alex probably has seen this quite a lot, there are these horrible, horrible collection points for trash in the ocean. And the bulk of that trash is plastic bags from grocery stores, plastic water bottles, and plastic straws. So should you need guidance, I give water bottles to my buddies. I carry my own coffee mug, I carry my own water bottle wherever I go, as many of you know. It's easy to do, and it saves all that plastic. And I just bought a glass straw with an adorable little glass echo on the side of it. So if you're looking for fun gifts for your grandchildren and children, they have amazing straws. They're not breakable, they're covered. They've got turtles and they have fish. And I got a lovely environmentally made hemp carrier for it, so you can carry it around wherever you go. So you can stop getting those plastic straws and think twice when you get those straws. You can see the numbers. It's astounding and atrocious, and so hopefully you all care about our oceans soon. So there's your environmental pep talk.
Hemp isn't legal in Utah.
I think the little covers You don't smoke it or eat it. I suppose you could smoke it. I didn't hear it's not from Boulder. I thought Utah, I thought I just read that Utah is close to passing marijuana. So they'll have to have some hemp-related products for the edibles or whatever. How many spoken about it? I have a cousin who's been through pretty grim cancer treatment, and she is using marijuana edibles, and she said it is amazing how helpful it's been for her nausea and just not feeling good. So if you know anybody going through that, I kind of kiddingly said, if you need me to get you any marijuana, let me know. And she said, oh, I've already got the edibles, my doctor already recommended them, I'm doing them. She's from a pretty conservative side of the family, and so we're pretty impressed that she was doing that. So anyways, there's your environmental purpose. Yeah.
Yeah, I'll talk about that. Hawaii. Us, Hawaii.
Although, you know,
Remember, another thing we did.
Take it over. Nothing that's. Not really.
And to make it sexist.
Right.
Whatever reason it I was reading that cartoon and everything. No, about the court case where a guy was raped. It's played out. Birds trying to fire. He's one thing he's possession. Right, where the lawyer bucket is back. I thought he was doing this. Boy.
Yeah, all right.
Probably. So, he said the good news is.
Whether or not,
No audio.
Yes.
Oh, I turned the volume down.
Channel. So I can just log into this, I assume to get my slides, I just got Google Slides, and I just log in, and there'll be sound. That's cool.
But no audio.
What's that? There will be audio?
I'm trying to figure out the audio.
Okay, so I got a video to show.
So just, I'm gonna show you this. This is a new drone that lets you, they're just coming out with it, and it does motion control. So it follows your hands, it follows your face, it sees you. You can go like that and take a picture. Anyways, this is the new one they're coming out. It's all self-contained motion control. You don't even need a controller.
Selfish for the selfish.
Yeah.
Small, colorful, smart. A powerful flying camera that you can take anywhere.
Oh, it's trash.
It's so clever it activates by recognizing you. Just launch it from the palm of your hand. It even returns when you call it and land like this. Easy. Can't get everyone in the shot? No problem. Watch as it hovers precisely in place, always at your command. Control it with your hands, remote controller, mobile device, or DJI goggles. Using GPS, Spark knows where it is, even if you don't. It'll even sense obstacles to avoid things in front of it and come home safely. Think you got smooth moves? Spark's footage is smooth. It takes the shake out of your shot, so you look like a pro. Not feeling the control sticks? Perform preset flight maneuvers with a single click and get those epic shots. Here's a way to stand out from the crowd. Spark automatically adds showy depth of field to your photos. If you don't know how to fly, just tap fly. Let's see if you can handle sport. Spark keeps you in the frame, so all you need to do is act naturally. Edit your epic videos and share them instantly. Spark your area of creativity anywhere. All you need to do is seize the moment.
Yeah.
The problem is now they've got so many rules. I mean, all of them, I mean, I looked at half of those videos, and half of them I'm like, I don't think you can even do that in my city. I don't think you can do that, you know, I mean, it's like there's so many rules now.
This is just barely over the FAA regulation, which.
What they sell it for, they know what
It's $2.99.
It's just barely what?
It's $2.99.
What are you gonna say about the FAA?
Oh, well, they overturned the FAA registration of drones. It's illegal to force citizens to register their hobby devices, so you no longer have to register your drones.
It's illegal to register.
Technically, it is. Some guy from the American Modeling Association sued the government back and won. Said you can't do this, and they're like, oh yeah, you're right. But it doesn't. They have no way to undo all the people that have registered. So the data's there if you did it.
What's the difference between that one and the one you have today?
So. Do I have time?
You have to do it.
The one today.
The reason I'm standing here is to also give you the pressing news that in the effort to save money, we are having an afternoon break, like beverage refreshment. You don't get a snack, so that cookie was it. Trying to make you healthier, happier, and we're saving money because Kelly's spending money wildly. So.
He's going to Hawaii to scout out the locations for us. So the difference between this one and the one I have out here is it's a lot smaller. It's about this big. It doesn't look like it, but you can actually, with no controller, no camera, like walking out here today for our picture, I could have held it in my hand, tap it twice, it takes off. You step back from it and control it with your hand. You tell it where to go with your hand, up, down, right, left. And then you just walk away from it, and then you go like this. The lights in the front flash, gives you 5 seconds, and you pose, and then it takes a picture. And you go like this, and it comes, flies right back to you. Lands on you.
It's $300.
Yeah.
So you'd like get 4 of those for the price of an iPhone.
You could. Yeah, for the price of an iPhone 8.
In that particular example, would there be also be an app so you could see what the picture was looking like?
So, yeah, so if you want to pull out your phone and connect to the Wi-Fi that's built into the device, you can control it with your phone and see the streaming video. Up to 80 meters or something like that off your phone.
How long does it fly for?
Flight time is 16 minutes.
What's the camera resolution?
1080p stabilized. It's not 4K, so that was.
$1080p is almost unwatchable, it's so great.
HD is so nice.
I'm gonna be out here today.
Where do you like your two?
What is it? 3 nights? 4 nights? 4 nights.